Hi everyone and welcome to the Python crash course. In this 5-hour tutorial, you're gonna learn everything that you need to take your skill level from 0 to hero. So this course is really going to suit everybody because even if you have some background with programming or you just started to program, then this course is really what you need to be extremely comfortable with Python. Now, throughout this tutorial, we are really going to start from the basics. And as we keep pushing to more advanced topics, then I will give a lot of exercises that I will also solve them by myself. So it will really give you a great sight of someone else solving programming challenges. Now, Python is still the most popular programming language in the world right now, so sticking to this tutorial could be really a wonderful addition to your programming resume. And also, after you finish this tutorial, then you can always come back and watch some of the parts of this video, and also you can visit the full documentation of this tutorial that I prepared for you. So this documentation is really going to include everything that I will be covering in this tutorial, and each folder in this documentation represents a section in this tutorial. And of course, the link is down below in the description. Now, one quick side note before we start. This crash course is probably one of the biggest projects that I worked on lately. So your support here will mean a lot to me. So before you go further with this tutorial, go down below and hit the like button for this video. And also feel free to share your thoughts about this tutorial and I will read each comment that you write. Alright, so let's get started. Alright everyone, so that will be the first section of the entire tutorial. Now, as you could see, I am inside a website that is called python.org, and this is the official website of Python for all kind of download links. Now, the reason we need to download Python itself to our computer, it is because our computer should understand the Python syntax, and this is why we should go ahead and install the programming languages libraries to our computer, and it will be as easy as hovering our mouse here and go to Python 3.9.1 like that. Now, there is a great chance that by the time you watch this video, this should display you Python 3.10 or Python 3.11. Now, I would suggest still to download Python 3.9.1, basically just to avoid some confusions if the code that I'm running on my local machine is not going to behave as on your computer. So this is why my recommendation will be to install Python 3.9.1. Now, a quick side note before we go ahead and install. You'll see that this title here says us download for Windows, and this is because the website automatically recognizes the operating system that I'm currently working on. So this should display you something else if you work with Mac or with any kind of Linux distribution. It will be as easy as clicking the link in here, and this should go ahead and do the job for you. Now, for sure, if you use a Linux distribution without any graphical user interface, then you could use the specific command for installing packages and just specify that you'd like to install Python within that command, and this should go ahead and do the job for you as well. Okay, so now let's download Python, and the second that it downloaded it, then I'm going to click on it and continue on with the installations. Now, before you go ahead and click anywhere in here, it is quite important to mark this checkbox in here because not clicking in here could mess things up, and this is something that is going to add some additional information to your system environment variables, and this is a critical process to make this Python work successfully on your computer. So make sure that you go ahead and click this checkbox, and right after it you can click on install now, and as soon as this completes the installation, then it will mean that Python installed on our computer successfully. Alright, so this should be the window after the installation. We should receive setup was successful. Now, in that stage, if you have any kind of problem or something went wrong, please write this in the comment section so I can really help you out to go further with the next installation. So I will close this window and continue on to the next tool that we are going to install. Alright, so now that we finished with the installation of Python, then we should go ahead and install some tool that will help us to write the Python code inside of it. Now, for this purpose, we can use any text editor we want, but there is also something that is called Integrated Development Environment that is quite more advanced than just a random text editor like a Notepad or Sublime Text. So we could basically go and install an IDE that is called PyCharm, and that is a very friendly IDE in my opinion, especially when you work with Python. Now, if you already have some background with working with different IDEs, then there's a great chance that you worked with Visual Code. And of course, you can use it for this tutorial as well. Just make sure that you configure the Python correctly to Visual Code itself. Okay, so you could see that we have professional and community versions in here. Now, we are going to install the community version just because the professional version is going to expire in 30 days and you might want to avoid that. Now, you could see that there are also links for Mac and Linux. So depending on your operating system, you can basically choose what to download. So since I use Windows for this tutorial, then I'm easily going to click on download in here and the download should start automatically. Now, if you see that it does not start for you, then you can go ahead and click in here, which says please use direct link. So I'm going to click here. Okay, so now the download has been completed, then I can open up the PyCharm installation and proceed there and basically click next to everything that is necessary. Alright, so in this installation wizard, it will be as easy as clicking next in pretty much everything in here and basically just click next until you see some installation has been started like that. Okay, so this is the window that we should expect to see after the installation completes. Now, I would recommend to click here just to basically start PyCharm immediately right after we click finish. So I'm going to do that and we will wait until the PyCharm loads. Okay, so this is the window that we should expect to see right after the installation and right after we open PyCharm. Now, when we work with integrated development environments, it expects from us to open some project to really get some Python files going on and write the code in here. So you could go and click on new project and you could also click on open. Now, I recommend to click on open and basically direct this PyCharm to any folder that you will consider it as your workspace when you start this tutorial. So I will do that for the dedicated folder that I know that I'm going to write the code there. So once you click on open in here, then you can see that there is going to be some folders that you can decide where you'd like to point this PyCharm. Now you could see that we have this new TUT folder that I already created before recording this video. So you should basically go and do the same thing as well. So just choose a folder that you'd like to consider it as your environment and then basically click OK. And once we click on OK, then a window like the following should appear to us. So this is the PyCharm itself, and in here we are going to write our Python code. Now, there is few more things that we want to verify in here before we really start writing some code. So you want to go to your file and click on settings like that. And in here you are going to have several configurations that you can change. So we want to click on project in here and we want to click on Python interpreter. And we want to verify that this Python interpreter is really pointing to some Python file. Now, this file is actually what is responsible to execute our Python code. So this is why PyCharm should know where it needs to point itself to really make our Python code to execute successfully. And you want to make sure that it points to this exact location, which is looking like the following. And if you have any trouble or you don't see anything that is set up in here, then you want to click on this drop down and click on show all, and there's a great chance that it might show in this window and you might want to click on one of those and basically just click on OK, and this should do the job for you. Now, if you still don't see the Python interpreter, which is supposed to be installed when we installed Python, then it means that something with the installation went wrong. And in here you want to double check yourself if the installation went properly, and maybe you want to reinstall Python. Now please make sure that in the next installation you also click on the add to path checkbox that we marked when we installed Python. Now, if this still does not work for you, then I would recommend to search for the problem on Google or basically ask me on Discord or in the comment section so I can really help out and see what is the problem, so it will be easier for you to go further with this tutorial. And one other thing that you might want to do here, and this is optional, you could click on the editor and change the color scheme of your PyCharm. So this means that you want to maybe change the color of the syntax highlighting, and I'm going to work with this Monokai syntax highlighting in our tutorial. And in your case it might be something else, so maybe you want to change the color scheme as well, and just for your information you can do it from the color scheme like that. Okay, so now we can click on OK and create our first Python file, and it will be as easy as right click, new, and click on Python file. And now I will name this, for example, 1, and now we are ready to go and we can start learning Python. Okay, so basically this is how the PyCharm IDE looks like in general. So in the left pane we're gonna see our files that we are going to work throughout this tutorial, and on the bottom we are going to see one more window that is going to be appeared once we execute our Python files. Now the way that we are going to start building our first application is simply by writing a basic program. Now in Python you have the built-in functions that allows you to perform some actions for you automatically. So I'm talking about functions that are mainly named on basic English keywords which we are allowed to use. So for example, if on your first program you want to basically show some text to anyone, then you can basically use the built-in print function. Now you can pay attention how I close the parentheses in here, and basically this means that we are calling a built-in function. So this is why writing only print is not enough. And inside here we can accept some information that is going to be provided as the text that we want to print. So in Python you have double quotes where you can mark your text, or you can also do that with single quotes. Now currently the differences between those are not quite important, so just go ahead with one of those. Okay, so I will start typing in hello to a new tutorial. Now the way that we can execute Python files is as easy as going to run in here and click on run. Now as I have done that, then you can see that we have a minimal box here that shows us which Python file we want to execute. So we will point to 1.py, and then you can see that we have our output right here. Now once we have done that, then basically on our next executions we probably want to do that a little bit faster rather than going to run and click on here. So you can use the shortcut of Shift F10, and then basically this shortcut will be responsible to identify the latest Python file that you have executed, and it will run it automatically. So unless we do not change the execution of the file, then just make sure that you execute your files with pressing on Shift and F10 combined. Now I want to focus for a second what is going on the bottom section of this window. So we can see that in the very first line here we have some meta information that shows us where our Python is located, which is right there, and as well as which Python file we execute. So this kind of information is something that we always going to see when we execute Python files within PyCharm. And then right after it, we can see the output that we show, which says us hello to a new tutorial. So basically we are going to see all of our print lines and additional information that we are going to print right here in the PyCharm, and we can minimize this page with the hide button in the right where my mouse is hovering. So this is also a great option to go back and see the full screen. So the next thing that I probably want to show about this built-in print function is that it is smart enough to accept more than one piece of information. So if I was to add a comma in here and add one more text like hello again, and go ahead and execute our program by hitting the combination of Shift F10, then we should see the output of those sentences as well. So you can see that we see the hello again right here. Now, another approach of completing this task will be for sure writing one more print statement and type in hello again. So this will be responsible to show those in separated lines. Now, for sure, there is an option to display some numbers as well. So we could go with something like, so I will delete the second line and I will type in some new sentence like my age is, and then we can basically add a comma here and we can add some number that we like to. So we can add here 25 and you can see that it shows us my age is 25. Now we can also see how smart the print function handles our sentences because it knows how to add a separated space right here, although we did not write something like that. So it is quite important to understand that as well. And I think this will be pretty much it about built-in print function. Okay, so in the following example, I also have a Python program, but this time we have the print line 4 times. Now you can pay attention how each of the print lines are describing something about some person, and you could pay attention that his name is John, and you can see how I repeat the name of John in each of my sentences. Now, doing something like this, it is a great idea because we can print a lot of sentences about some guy, but what happens if in the future you want to describe the exact same thing for another guy? Maybe you want to describe something about Jack or some other guy that his name is different than John. So this will mean that you have to change this John 4 times. Now, to prevent this and to write code that is considered as a best practice, so we will not copy ourselves, we have something in programming that is called variables. And what variables allow us? It allows us to store some information inside the Python memory when we execute some file. And then basically we can refer to that value by calling its variable name. So let's see an example of that in action. So basically I will go in the first line and I will jump a line, and you can see that now I can type in here some new variable. Now the way that I can create a variable is just picking a name that I would like to create and make that to be equal to some value that I like. So it will go like name equals to, and then I can make that to be equal to John. So in the next time that I want to write sentence with the value of John, all I have to do is going ahead and say print and then refer to that variable name that I have created. Now if I run this program, then you can see that we have the John at the very bottom of this window. So basically now it is a great idea to change all of our sentences to being more dynamic, and we can omit this John from here and we can go and print the name and we can add a comma, and then this will be responsible to show the exact same sentence like we had previously. So now if I execute the program, then you can see that we receive John is my name, although we don't write here John hard-coded. So we could do this for all the lines. So I will do that, and we can change this to be name as well. And we can do the same approach on the last line. So that time the comma will come after the sentence and I will say name. And once I have done that, then you can see that the results are quite great. Now, what is great with that? In any programming language, this is considered as a best practice because our main attitude will be to not copy ourselves as much as we can. So this is why the variables exist in any programming language, and it is really recommended to create as much as variables as we can. Okay, so just to summarize this topic up, you want to create variables because it allows your code to being looked more organized and it also saves time to copy and paste some values that you probably want to refer them in some certain cases. So again, this is the way that you can create variables. Now, if you come from another programming language, you might ask yourself if you have to define the type of the variables. So the answer for that is no. In Python, you don't have to basically declare what type of variable you are going to create. So it is as easy as creating them in the following way. So the following exercise that I want you to look up for is that changing this sentence to being a little bit more dynamic as well. So consider a situation where our guy is now Michael and he is actually 30 years old, but I want to store his age on a new variable and to display it on the sentence in the fourth line. So just pause the video for a moment and try to do that, so it will give you a first experience to try to do things by your own. Okay, so if we said that Michael is 30 years old, then it is a great idea to go ahead with a variable like age equals to 30. And now we should customize this sentence in here. So we could say, for example, we could delete that and we could go with is, and we could add one more comma, and now we could refer to that age variable by easily saying age, and we could add one more comma and we could say years old. Now this should be enough to display Michael is 30 years old. So let's go ahead and try that. So once I have done that, then you can see that we see in the second line here that the sentence is Michael is 30 years old. So this is the way that you can achieve that. Now, two more important points that I want to shout out here before we move on to the next topic. You can see how I create a comma and I always add a space right after my next information. So it is just a convention in Python as well. This is just looks more cleaner than this and this. So just make sure that you follow this convention as well, so it will make your code look more clean. And one more important thing that you might have noticed until now is that if we take a closer look to the sentence in line 7, then you can see how our sentence is inside double quotes. I mean, it is wrapped with double quotes. And then we could use a single quote inside the double quote. Now, you could also think how we are allowed to use single quote inside a double quote, because we said that in the beginning of this tutorial you could go and create strings with single quotes as well. So basically the use of the double quotes is exactly in these cases when you want to refer to your single quote as an apostrophe in an English sentence, for example. So in that case, if I was to change this to a single quote sentence, then you could see how I would start receiving errors, because the Python thinks that this apostrophe is actually an end sign for a sentence. So this is why you could avoid this with creating those sentences with double quotes like we did previously. So this is also a point that I wanted to specify before we move on to the next topic. Okay, so in the last topic we understood how we can create variables, and you could pay attention how we created some different types of variables. So some variables were variables that are wrapped with single or double quotes, or other variables were just numbers. Now in this part we are going to divide all types of variables that we have in Python. Now you did not see me doing this before, but basically when it comes to developing projects, you have the feature of commenting some sentences that are designed for personal use. So for example, you are writing a basic program and you also want to describe its goal by writing some very minimal documentation. So you can do that by writing comments, and it is as easy as starting your sentence with an hashtag sign. So basically, this is a comment about this Python file. So you see, if I was to delete that, then the Python could actually think that this is a code that it needs to execute. But since we added the hashtag sign, then the Python can understand that this is a comment, and we are going to use this a lot to describe new topics that we are going to learn. And you yourself can use it as well if you want to add some additional information to the code that you write. Okay, so moving on the topic that I'm going to talk. You saw me creating those name equals to John and age equals to 30 variables. Now you could pay attention how this is wrapped around double quotes and this is not. So this is a variable type and this is a totally different variable type as well. Now in programming languages we like to categorize those variable types so it will be easy to remember what kind of variables we create in the future. So variables that are going to include some letters or basically are wrapped with single or double quotes, we tend to call them strings. So basically strings are going to contain some characters that we want to create or store variables. It is more right to say that. Okay, so this is why we use strings in any programming language. Now, if you were to write some program with complex calculations, then you will probably go ahead and create a lot of variables with types of numbers. And the numbers that are not containing any decimal point, we tend to call them integers. So integers are numbers without decimal points. So until now we have those two variables, and in Python we have two more important variable types, and the next one you can probably guess that it is a variable type that is going to always contain a decimal point, and we tend to call them floating numbers or floats to say that a little bit shorter, and those are numbers with decimal point. So this could be, for example, temperature, okay, and this could be equal to 90.5. So this is a floating number because it has a decimal point. And we have one more type of variable that is describing some situation, whether it is true or false. And those variable types are called booleans. So booleans are variable types that is pretty special, and their value could be always true or false. So for example, we could say is raining equals to true, and pay attention how the Python recognize this as a built-in keyword, and also pay attention how I did not write true like this, so it is important to realize that. And we could also say here false, and remember that true or false are the only values that could be booleans. Describes a situation, true or false. Okay, so this is a nice comment to write here as well. And those all the variable types that we have in Python programming language, so it is important to being familiar with each one of those. Okay, so now that we understood what are the different variable types that we have in Python, let's go ahead and try to understand this in a program that we will develop together. Let's try to develop a program that is going to calculate the average temperature between 2 days. So I will allow myself to delete those lines here, and I will start creating two variables that are going to simulate different temperatures between different 2 days. So let's say temperature 1 equals to 95.5. And let's also say temperature 2. So I'm doing this a little bit faster here. And I will say here 94.5. Okay, so we should write a program that is going to return us 95 because obviously this is the average between those two numbers. Now the way that we can do this is by print. And we could start writing regular mathematical operations between those parentheses in here. But we could also do something like the following. So before we go ahead and write some extra information inside our print line, we could say average equals to temperature 1 plus temperature 2 divided by 2. So you see, we could operate the exact same operations like we have in real math. Now also it could be a lot nicer if we would wrap this addition in parentheses, because in mathematical laws the division will come first. So if we wrap those with parentheses, then this operation will execute first. Okay, so now that we have done that, we will try to print the average in here. So if I execute this program, then you can see that we receive the result of 95. But there is something that is quite annoying with this result, and it is the fact that we see the result as a floating number. Now you could see how this is not necessary to display here the dot zero, and also it might be a great idea sometimes when you want to calculate average or something to avoid using decimal numbers as a result. So this is why in Python programming language we have some built-in functions that allows us to convert between different variable types. So let's have a quick look for the built-in functions that will allow us to convert between different variable types. So we have the str built-in function. So I will write those in comments. This will do conversion to a string. So we will type this down here. We'll convert to string. And this is the int will convert to integers. And you can already guess what is going to be for the rest of the variable types. So we have float built-in function, and this will convert to floating numbers. And in here we also have the option to convert from any type of variable to boolean. So this will convert to booleans. Okay, so now that we understood that we have built-in functions that allows us to convert between different variable types, let's see one of those in action. So if you remember, I said that we would like to receive only 95. So I could go here and we could change the information we provide in the print statement, and we could call the built-in int function. And as an information that I'd like to convert from some variable to an integer, I will provide here the variable of average. And once I have done that, then the print built-in function should show us the average in integer version. So if I execute this program, then we could see that we receive 95 right here. Now let's give some more examples where the conversions could be extremely useful. So for example, you might have some cases where you want to just concatenate some digits. Now let's show an example of that. So I will allow myself to get rid of the temperature program in here. So I will delete those lines. So now I will write a program that is going to concatenate different digits. So say that we have digit underscore 1 equals to 1, and we have digit 2 equals 2. Now let's say that I want to display the number of 12. So you might think that we should go with something like print, and we should write digit 1 plus digit 2. But with this approach, we would receive 3 because this is operating the actual addition like in math. So if we want to have the number of 12, we have to convert those into strings. So the Python can understand that it has to concatenate different strings. So we could go here and we could wrap this with the str built-in function, and we could do the same for the digit 2. So we could write here str, and as an information we could pass digit 2. And now if I execute this program, then you can see that we receive back 12. Now this is something that also could be useful when you work with conversion types. So as you see, you are allowed to convert to any data type that you want. from any data type that you want. But you also want to make sure that your conversion is valid. And what I mean by that is, for example, let's say that we again delete this entire program here and we type in name equals to Jim, and we go ahead and we try to convert this to an integer. We will receive an error because you cannot convert characters to an integer, so you always want to make sure that your conversion is valid and it makes sense. As you see, we have here some output that shows us that we have a value error. In this section, we are going to learn about the built-in input function of Python. Now, to simulate you what it does, I'm going to print here one question that asks us how is the weather today, and you can see that the answer for that is right in the second line as a print statement. Now, if we execute this program, then everything runs successfully. Now, we ask ourselves how we could answer this kind of question while the program is running. Well, for that, we have a designed built-in function that knows how to receive an input while the program is running. So what is so special with the built-in input function? It knows how to stop the execution of the program until you write some information to it. So if I was to change this statement from print to input, then our program would actually wait until we put in some information. So I will allow myself to delete this print line from here, and I will only execute this input line. So if I run our program, then you can see that we do not receive the message that our program is exited. So what that means, it means that our program is still running and it expects for an input from us. So we could say here sunny, and only when we press enter after this input, then the program will exit because there are no more lines of code to run. Now you probably ask yourself how we can gather the information that is received from this question. Well, the answer for that is as easy as assigning this entire statement to a variable, because the input that you are going to put in is going to be stored right in this statement. So we could say answer equals to, and then this will be equal to that entire input. Now, as we have the answer stored in the answer variable, we could basically write a print sentence that says the weather today is, and then we could add the answer itself. So now we can test this program, and again the answer variable is going to store whatever we type in when this line executes. So if I re-execute our program and then I will write here sunny, then you can see that we receive the message back that says the weather today is sunny. Okay, so this is what basically the input built-in function does. So we execute this built-in function while we put in some information that we want to show, and then it knows how to stop the entire execution of the program, and it knows to store the provided answer inside the variable that you are going to assign to. Now, before we go further, I want to show you some more example of what input function could do. So to show you that, I'm going to change this answer to something else so we can understand it. So I'm going to ask what is your age, and then add a question mark, and then I will say here your year of birth is. So I'm going to calculate the year of birth of whatever person it is based on the age that I'm going to receive in this line. Now, to actually calculate this, we have to provide some calculation. So we could say as the first line something like the following. So we could go with current underscore year equals to 2021, and we could say down below that we want to return the year of birth, but now we actually have to do a subtraction of the current year with the answer. So we could go with current year minus answer like that. Okay, so once I have completed this, this is actually the exact stage that I wanted to reach. Now you could see that we received some warning that says expected type int but got str. So what this means, it is actually something that reminds us of what we did in the previous section. So the input function is automatically going to store its values by string. So this is why PyCharm warns us that we cannot subtract an integer with a string. So what this means? It means that we have to apply a conversion. Now we could go and do this by easily going here and convert this to an integer. And if we execute our program, then we could say, for example, 29, and then we receive the message back of 1992. Okay, so one more thing that I'd like to show here. Not only you can convert the answer here, but you can actually force your inputs to receive an integer automatically. So what that means? It means that you don't have to convert this answer variable every time that you want to see its integer version. So we could delete this from here, and we could remove the parentheses here as well. And now you can see that we have this warning back that the subtraction is not allowed. So we could do this by easily converting the entire input to an integer, and that way we don't have to convert the answer to an integer every time that we want to refer to that variable. So we could say int in here, and that will work as well. And as you can see, the warning in here is disappeared. And if I execute the program in that way and write here something like 35, then you can see that the output is back and we don't receive any errors. So this means that this approach is also fine. In this section we are going to learn how we can visualize our strings a lot better, so everyone will have a comfort way to display some advanced strings to our screen. So let's bring back for a second the program that we have completed in the previous section. So if you remember, we used the current year variable and we assign it the value of 2021, and later on we displayed some different strings in our screen that calculates the year of birth regarding to the answer of the person about his age. Now let's say that I want to print a sentence that is going to say that current year is 2021 and the next year is 2022. So it will be something like the following. So we can start with saying current year, and then we could add a comma right after we close our double quotes, and we could say current year like that. Let's actually add an is in here, and we could add one more comma, and we could continue on by writing dot to close the previous sentence, and we could say next year is, and we could again write a comma after our double quotes, and now we could say current year plus 1. Now this sentence is going to print the thing that I wanted to print, but if you actually pay attention, in the third line we repeated a lot of times the process of writing a sentence in double quotes and then add a comma, and then we done that like 3 to 4 times. Now this is something that we could prevent by using something that is called formatted strings. So by using the formatted strings, we earn to display messages a lot better and a lot dynamic, and it also doesn't force us to always add commas and close our strings with double quotes and stuff like that. So let's see an example of how this exact sentence could be implemented with formatted strings. So I will go down here and I will say again print, and this time before I open the double quotes, I will type in the letter of F, and then I will open my double quotes. Now this says to the string above that this is going to be formatted string, and what it means is that you can refer to your variable values by inserting their name within a curly brackets. So what that means, it means that if I was to open here a curly brackets and say current year, then this entire thing would return me the value of current year. So let's see that in action. So I'm going to execute this program, and now you can see that the only sentence that we got from this thing is actually 2021. So let's actually go ahead and convert the third line to a formatted string so we could have a lot better way to visualize this sentence. So we will start by saying current year is, and then we will add a space, and then within the curly brackets, like I said, we could refer to the variable's value within a curly bracket, and we could write a dot right after we exit our curly bracket, and we could say next year is, and then we could open those curly brackets again, and we could add here anything that we want, and PyCharm will understand. So we could say current year plus 1, and this entire thing is going to be translated into 2022 like it was in here. But the only difference between those two, let's actually zoom out a little bit so we could see the differences a lot better. Now you can see how this looks way more organized than this one, and it also saves time to always close strings, open new one, and always add commas. So this is the more common way to actually display dynamic strings and things that are more advanced. So from now on, I'm going to use the following approach, and that way is actually what considered as a more common way among Python developers. In this section, we are going to learn about methods, what are they and why do we need them. So as you see in the following program, I have this line that says name equals to John Doe. Now you could pay attention how the J is capitalized and then the D letter here is not. Now this is something that is quite not nice, and we'd like to change it in some way without hard coding in capital D. So the way that we can do this is by using some method that will be responsible to show this name in the way that we want to. So if we were to go name dot title, then close parentheses like that, so this entire expression will be responsible to give back the value of John Doe in the way that we want. So this is why it makes sense to grab this entire expression and wrap it around a built-in print function which we are very familiar with. So I will do that, and I will go with print in here, and I will close the parentheses in the end of this line. And now if I execute this program, then we should expect to see the John Doe in the way that we want. So the point behind that is that we are having some methods that are dedicated to each data type. So for example, if I was to go down here and say age equals to 25, and then go again with a print line and say age dot title, and then close the parentheses up like we did exactly in here, this is something that we cannot do because this method is not included as a method that is available for strings, and this is why it is actually marked with a yellow background in here. So this means that this method is not allowed within integers. Okay, so it is very important to understand that each data type has its own methods that you can use. Okay, so now that we understood the methods in general in Python, I want to show you something else. So let's delete those lines from here. And let's actually customize this print line a little bit. So I will allow myself to delete this temporarily. And I will type in a formatted string. So this is something that we learned in the previous section. And we could say title is, and then we will add a colon. And we will call those curly brackets that we know already how to use. And then we will print the name. But we want it in the way that is title. So we should use the dot title in here. So if I run this, then we should see title is John Doe and the D is capitalized. Now, the question that we ask here is if we go ahead and type in print name, do we expect to see this same output because the dot title overrides the value of name? So this is an important question that we ask ourselves in this stage because this is a method behavior that we should be familiar with, and let's actually see the results. Okay, so if I go and execute our program, then you can see that the John Doe is still in the way that it is declared in the very first line. So what that means? It means that the methods are not going to override the actual value of the variable that you are applying the method for it. But there are going to be some methods in the future that will override the variable itself, but this is not relevant for now. We will see that when we discuss about some other variable types. Now, if we want really to override the variable of name with the titled version, then we could do something like the following. So we could delete this entire line from here, and we could say name equals to. So I'm redeclaring the name by saying name.title, and this will work because now we execute this line and the value of name is saved in the Python memory, and now I am reassigning it again, but the Python memory doesn't know currently the new value that is going to arrive. So when I execute this line, then it is going to look up for that line and it is going to reassign the name variable. So this is why it is going to be overridden. So if I execute that line, then you can see that the result is John Doe, like we expect. Alright, so in the following section we are going to talk about the different methods that we can apply for different strings. Now you can see that we have the exact same line of name equals to John Doe like we did previously, and we can also see up top here that I commented out some lines just for documentation reasons to really remember what are the most common methods that we can use on our strings. So if you remember, we learned about the dot title previously, and you can see that I described it as a method that will capitalize each word on the string. Now to simulate what rest of the methods are doing, let's actually write some code. So we will say print, and we will type in a formatted string, and I will say title, and I will write a colon. Now this is only for documenting reasons, so I'm only showing what title method will do, and then later on I will just call the title method on the variable of title. So it will be name.title wrapped around the curly brackets. So if I execute this line, then you can see that the title is John Doe and it capitalizes each word. So let's apply the same approach for the other methods. So I will copy and paste myself 3 times. And then we will change this to capitalize to see its behavior. We will type in here upper and we will type in lower. Now as I have done that, then we should also change the methods itself and not the string just for documenting it. So we can say here name.capitalize, and we can say here upper, and we can say here lower. And now if I execute our program, let's take a deeper look for the results in here. So I will zoom in the output and I will scroll it up a little bit. Now the capitalize method is only capitalizing the first letter no matter how much the string is including. So even if it has 20 words or 100 words, it is only going to capitalize the first letter of the string. And you could see the behavior in the upper as well. It just turns the entire string to uppercase, and the lower as well, turning all the letters to lowercase. So those are the most common methods that you can apply for your strings, and they basically allow you to visualize your strings in a better way, and you can just play around with them whenever you want. In this section, we are going to learn about the different math operators that you can apply on floats and on integers. Now, as we saw on string methods, we had some keyworded methods that is going to change the string itself. So you might have expect the same behavior for the integers and floats as well, but the case for that is actually a bit different, and the Python programming language basically supports all the arithmetic operations that you are probably familiar with from the math classes. So if you want to perform an addition for two numbers, then you can use the plus sign, and as well as for subtraction you can use the minus sign, and the same goes for division. And we also have support for some different operations that are pretty much unique for Python. For example, division without remainder, as you can see in the comment section, we have it as double forward slashes. So let's basically go ahead and see the behavior of each one of them. So I will start with this operation 3 plus 2, and we are printing the result in a formatted string. So if I run this program, then you can see that the result is 5. Now for sure, if I change this to minus sign, then the result will be 1. And let's actually see what will happen if I divide 3 with 2. So if we print this out, then you can see that we receive 1.5. Now I'd also like to show you some more different things that we have in Python. In Python programming language, we also have some built-in function that is responsible to bring us back the type of the variable itself. So you could already guess that the action variable is not going to be integer, because we see 1.5, which is a number described with a decimal number. So we could basically go inside this action here and say type, and we could wrap this up with the action variable itself. And it totally makes sense to change the string here for a minute. So we could say the type is, and we could leave it as it is. And now if we go ahead and print this out, then you can see that we see class equals to float. Now I want to show you the difference, what will happen if I basically add here one more forward slash. Now as you can see from the description in the fourth line, it is going to return us only 1, because this is designed to return the result without the remainder. So now if I print this program up, then you can see that the class has been changed to int from a float. So this is an important thing to understand, and it's also a good idea to understand really the behavior of the type built-in function. So if you want to print out the type of your variables, then you have that option, and you can do that with the type built-in function. Okay, so let's continue on for the rest of the actions in here. Now I will allow myself to do a couple of Control Z's in here. So we will undo the latest changes, and we will continue from here. Now if I change this to multiply sign, then you can already guess that this is going to return us 6. And we also have the option of power. Now when we go ahead and hit the double asterisk sign, basically the number that comes after it is going to work as the power number. So this should return us 9, and this is exactly what happens. And we also have the percentage sign, which is responsible to return us the modulus. So as you could guess, the remainder when you divide 3 with 2 is going to be 1, so this should return us 1. And this is also an important math operation that you probably want to be familiar with. In this section, I'm going to show you how we can consume external Python libraries. Now, when we went ahead in the beginning of this tutorial and installed the Python programming language, basically the installation included some external libraries that it installed to our computer. So what that means, it means that Python has tons of libraries that we can use for our needs in any project that we would like to develop in the future. Now, you might ask yourself in this stage, what is a library? So a library is basically a Python file that includes a bunch of built-in functions that you can consume and use for your different needs. So say that you want to operate some mathematical operations that are way more complex than what we have learned till this point. So this might be something that is not actually built in when you go ahead and don't use any external library, but this might be something that is already existing, and those functions could be actually existing inside an external library. So to really give you an example how we can consume an external library, then I am really going to use an external library to operate some more complex math operations rather than what we have learned in the previous stage. So to bring an external library, we can use the built-in keyword that its name will be import like that. And to really import the library itself, we have to refer to its name. So we can do that by using its name, and in my case, the name of the library is math. Now, the second that you imported the library, then you can go ahead and access its functions. So you can say math dot, and then you can see that there are a lot of functions that you can use inside the math library. And now we can say here that we want to use some built-in function inside the math library. Say that we want to use the seal function, and I will explain what it does in just a minute. So to really have this function run successfully, then we can create some floating number in here. So let me create a equals to something like 8.2, like that. And actually the seal function is a function that is designed to round up your numbers. So if you were to pass in here an information like the a variable, then it will go ahead and return you 9. So it just takes the given floating number and it rounds it to the next integer. So in our case, this should give us back 9. And if we really bring this and assign it to a new variable, let's say that we will name it b, and then we go ahead and print its value, then you can see that it returns us 9. So that is the seal built-in function, and we can use more functions within this library, right? So let's say that we want to use the floor function, and that function will do the exact opposite action rather than what we have seen in the previous example. So this should return us 8 because this will round the given floating number to the previous integer. So if we were to execute this program, then you can see that the result is 8. Now in this stage, you also might ask yourself, do we have a list of all the libraries, or how I can know each library and its name, because there are tons of libraries? Well, that is a perfect question, because I don't know a personal programmer that knows all the libraries, and that is perfectly fine because there are tons of libraries. So to really have a basic idea of some of the existing libraries out there, then I have a nice trick that will allow you to see all the existing libraries currently that are installed on your computer. So once you use the import keyword, since the PyCharm expects for a library name, then usually each IDE has its own drop-down options for the next expected value. So if you were to use the import keyword like in here, and then right after it press Ctrl space, then it should throw you a drop-down with all the existing libraries that are currently installed in your computer. And as you can see, I keep scrolling down and there are a lot of libraries that you can really use. Congratulations, you completed the first hour of this Python full course. So let me know in the comment section how you did with the tutorial till this point. Now from here, I will create some small projects here and there, and you can try this first by your own, and I will do a walkthrough for the solution of those coding exercises. And also don't forget that for each section you learn here, there is a documentation that I prepared for you that you can take a look after completing the entire tutorial, and you can find the link for it in the description. And if you enjoyed the video, hit that thumbs up button. Your thumbs up is very meaningful to me and could help us to reach more people. In this section, we are going to focus on something that is called expressions. Now, till that point, we saw a lot of operations that returns us back the variable type of integers and floats, and that is totally makes sense because we use some math operations that we probably all familiar with. And we also saw different string methods that you can apply for each of your strings. But currently, we did not see any special Python code that will result in to return us back the variable type of booleans. Well, this is something that is possible if you go ahead and create some expressions within your Python programs. And the reason you want to know how to write expressions at this stage, it is because they can allow you in the future how to condition your code execution depending on the result of the expression that you create. And we will learn how to do this very soon in this tutorial. So an example for an expression could be something like the following. So say that you want to check if one number is bigger than another, then you can go with something that is going to look like the following. So I will name my variable a, and that will be equal to something like 5 greater than 4. So in order to create expressions, we are going to see a lot of different operators that you have probably see from real life when you solved some equations from math classes or something in that kind. So the thing in here is called an expression, and this will result in to return us the value of true or false, meaning the variable type of boolean. And if I go ahead and actually try to print this variable, then I will receive true because this is an expression that is basically true. But if I was to change that operator to less than and try to re-execute our program, then we will end up with false because 4 is not greater than 5. Now, as you can understand, we have a lot of operations that will allow us to basically compare between the left side to the right side of whatever value you put in. So a greater example of that could be also implemented with strings as well. So say that you want to compare two strings and basically check if both of them are equal. So in that case, you might think that this could be possible by easily using the equal sign again. But the case is, if we go ahead and actually try to do something like the following, so I will say John equals to John like that, then we will end up by receiving some errors because the single equal sign is mainly saved in Python for assigning variables. So to overcome this, what Python expects from us to do when we want to compare two values like the following situation, we can do that by using the double equal sign, and basically now this entire area is an expression that is for sure going to return true because John is actually equal to John, and that is why we see true. But just to mention off, if we were to change this to lowercase, then this will result in false because this one is in lowercase and this one is not, and this is why we see the result of false. So now let me put in all the expressions that are existing in Python that we can basically write any kind of expressions with them. Alright, so let me paste in quickly all the options that we have to write some expressions with. Okay, so as we saw, we got the double equal sign to basically compare between strings, and you can do that for numbers as well, and we will see an example of that just in a minute. And you also might want to use the not equal sign for some cases to check if something is not equal to another thing like a number or a string. So that will be by the exclamation mark and then the equal sign. And as you can see, we also got the greater than and less than, and we saw examples for them just in the beginning of this section. And we also got some operations that are combined. So the combination is actually the greater than or equal to. So this is why we use both of the signs for greater than or equal to, and the same approach goes for the less than or equal to. So those are the 6 main operations that you might want to use when you want to write some expressions within your Python code. And let's actually paste in some examples for all of the 6. So I'm going to paste in some examples and let's have a look on them in here. Okay, so we got the print lines for all the expression examples, and we got the 5 equals to 5 that should return us true, and we also got the 5 not equal to 5, and as you might have expected, this should return us false. And same goes for 5 greater than 5 and as well as 5 less than 5. And now, since we have combined the greater than and equal to, then both of those lines should return us true. So let's test that out. So I'm going to execute this program, and as you can see, the order of the outputs in each line is actually just as expected. So that means that now we understood all the expressions that we might want to write in Python, and in the future we are going to see some more complex expressions that we are going to use within more complex variable types, but those 6 should be more than enough for now. In this section, we are going to learn how you can condition your code execution depending on a result of some expression that you write. Okay, so in that example, I'm going to try to write a program depending on the result of the John's grade in the last exam. And as you can see in the description up top, I want to write a print message if John has actually received a grade that is greater than 70. So to do something like this is something that we did not learn how to do yet, but for sure this is something that is possible in any programming language. And the way that you can do this is by using if statements. And if statements basically allows you to condition your code execution whether if the expression that you provide in returns true or false. So the most basic if statement that you can start implementing in Python is looking something like the following. So since grade underscore John, which is the grade of John, is 80, then probably I want to print a message that says congratulations because his grade is actually greater than 70. So the way that you can start do this is by writing if, and this is actually a known keyword in Python, so this is why you can use it. And in here Python expects for an expression that will basically start implementing the if statement correctly. And as you can see, as I have hovered my mouse here, we see a message that says expression expected. So we will provide in the expression, and the expression will be grade underscore John greater than 70, like that. And now we have to go ahead and do one more thing to finalize this if statement, and that will be to add a colon sign right after it. Now the reason that you do this, it is because Python has to understand which lines of code to execute if this condition is true. And the minute that you give it a colon sign, it knows to create an area that is marked as an area of lines of code to execute if this expression is true. So that means that if I go ahead and press enter in here, then you can see that PyCharm did something weird and unexpected. It jumped the text editor right where my mouse is. And the reason that this happens, it is because it identified the if statement, and the way that you want to mark an area of lines of code to execute if this condition is true, it is by creating an indentation. So this is why every line of code that I'm going to type in here is only going to be executed if the expression in here is true. So it is very important to understand this behavior, because the indentation is something that is looking quite weird at the first look, but just remember it as a code block where Python will know if to execute the lines of code or not. Okay, so as we continue from here, let's say that we want to delete those lines in here, and we want to write in here congratulations, like that. And the reason I'm doing this, it is because John is actually passed the exam. So if I go ahead and execute this program, then you can see the output as expected. But if I was to change this to 60, you might have expect to see nothing, and this is exactly what will happen, because Python goes ahead and execute this if conditional, and it sees that this is not true, meaning false. So it is not even going to enter this area, and this is why Python ended up with executing nothing. But let's assume that we want to cover each case where this condition is not true. So what that means, it means that we want to do something if this is not going to enter this condition. So the way that you can do this is by basically exiting out of the indentation and use another keyword that is going to be connected to the if statement that is called else. And the second that I have done this, then again I have to create that colon sign. And again, if I'm going to press enter, you can see that the PyCharm automatically creates the indentation for us. So what will end up happen in here if I go ahead and type in print John has failed the exam, then in that case, the lines of code that are going to be executed in here is for sure the lines of code in the else area, because Python knew to not enter this area because 60 is not greater than 70. then it ended up to jump on to the else statement, because this is how the if and else are connected to each other. So if I go ahead and run this program, then we will end up with receiving John has failed the exam. Now let's also say that you want to print another message that says good luck on the next exam, and you can do this easily by exiting all the indentations and just running some lines of code after the if and else conditionals. So this means that we can press enter in here, but PyCharm might still think that you want to write some lines of code in the else block, so you can basically use the shift and tab combined to get out of all the indentations. So the second that I have done this, then I can go ahead and write something like good luck in the next exam, like that. And the second that I have done this, then you can see that we will always end up with executing this line, because this is not inside a conditional like if or else. So it is very important to realize that. And if I was to revert this grade to 80, then we will still receive this message, but we will also see the congratulations, and Python will ignore the John has failed the exam, because Python entered this area, so it does not have to enter the else area, because this returned it true, and this is very important to understand that. Alright, so now that we understood how if statements are working, I'd like you to take a minute to practice it. So the program should show a multi-lined message if John should go today to school or not, and that is going to be dependent on the situation of the weather. So try to display a message using the print built-in function only once. Now, I know that we did not learn about the displaying multi-line messages yet, so that is actually a good candidate for a topic to try to search by your own how you can do this, and I know that any resource on Google can help you with doing that. So consider completing this task by your own before I go ahead and show the solution of that. Alright, so the way that we can create a program like this is for sure starting it with an if statement, because we like to execute some lines of code if is snowing is true and some other lines of code if is snowing is false. So we can start our conditional by saying if is underscore snowing. Now you might think that we should add the double equal sign and then check if it is equal to true, like that. But actually this entire thing is not necessary, because the expression that you are going to provide right after the built-in keyword is automatically going to do its work by checking if it is equal to true. So this is why you don't actually have to provide in the double equal equals to true, because by default the variable type of is snowing is set to a variable type of boolean. So this is why we can take this off from here and continue the execution. Now if you remember, I said that we should only use the print built-in function once for that situation. So this is why if I go ahead and try to call this function, and actually let's add the f for formatted string, and now I can try to create the strings and use the double quotes. But now if I press enter, then you can see that PyCharm automatically added one more formatted string for me, and that is actually a one way that you can print multi-line messages. But another way that you can do that, maybe you saw it by researching on Google, you can actually provide triple double quote sign, and if you press enter in here, then you can see that PyCharm is fine with this, and we can continue provide our message right between those triple double quotes. So we can start this message by saying hi, and we could relate to the student underscore name, like that. And we could say in another line, you should not come to school today, because it is actually a snowy day. And now we can finish off this email by saying thanks school management, something like that. And that will be it for one of the conditionals. Now we understand that this is going to be executed only if the is snowing is actually true, so we like to provide the exact opposite action. So we can say else, like that, and we can go ahead and try to print the message for the false case, and we could use the triple quote sign again, and we could say hi again like that, and we can say today the weather is fine, so please come to school. And again we can say thanks school management, like this. And now that we have completed this, we could test our program. So if we go ahead and try to run this file, then you can see that we received the message successfully. So you can see that we see today the weather is fine, so please come to school. But if we were to change this to true, then you can see that the message has been changed. Now, something that might bother you in here, and maybe you handled this properly, I said that this email should be well written. So we could consider adding this dot title in here just to make this looking a lot better. So we could also do that in dot title here as well. And if we execute the program that time, then you can see that we see hi John Michael capitalized, and that is great because this is how we should display names for some people. In this section, we are going to understand how we can take the if statements to the next level. Now, if you remember from the previous section, we had a code that says is snowing equals to true, and we ended up with checking if it is true like that, and if it is, we printed this message in here. And also, if it is not snowing right now, then we are going to end up jumping to the else block and execute the lines of code right after the else statement. Now, if we think about it, these if and else blocks are actually quite limited because it only handles in cases where it is snowing or not snowing. Well, I'm going to ask you, what if now there is rain outside and we want to print a message that says it is not so cold outside, something like that. And so to actually handle this, we can end up with writing more conditionals between the if and else blocks. Because if we think about it, in that case, we only have a case where it is true or not true. But in programming, we might have some cases that is kind of in between. So to actually handle such a situation, we can go in here and exit the indentation. And we can say else if. Now actually the shortened version to spell else if in Python will be elif, so this should be enough to write some more conditionals between the if and else. So in here Python expects for a conditional like it expects in the if statement as well. So I'm going to say in here is underscore raining like this, and I'm going to make that to be equal to true, and I'm going to say here is raining and add the colon sign, and I'm going to print in it is not so cold outside like that. Let's actually make this to be similar for the other output, so I will add the apostrophe between T and S. Okay, so just for the testing, let me for a minute revert the is snowing to false and see what will happen if we execute this program. Now if we execute this, then you can see that we receive the it's not so cold outside, because what Python ended up doing, it checked if it needs to execute the code after the is snowing, and since this returns it false, then it went ahead to check the next conditional, and since the is raining is true, then it ended up with executing this line. Now I want to show you what will happen if we actually remain both of the is snowing and is raining true. So I'm going to change this back, and now I'm going to execute the program again, and you can see that we only see the result of it's extremely cold outside. And the reason for that, it is because Python looks for this entire code snippet as a one unit, and it knows that it should only go inside one of the indentations, since this is how the if statements works in any programming language. The Python interpreter will only end up executing one area among all the areas that we can specify in here, and it is because it ended up checking is snowing equals to true, and then it entered to this area, and then it said to itself, okay, so I already had one true conditional, and it means that I can ignore rest of the executions, and then it's going to out from this entire if and else block and continue on executing some lines of code from here. Okay, so this is really important to understand such a behavior. Whenever you see if and lots of else ifs and as well as the else block at the end, then it means that Python will look for this entire code snippet as a one unit, and it means that it will only enter to one of the indentations. Okay, so now that we understood the behavior of if, else if, then we have some more keywords to write some more advanced expressions in Python. Now, let's say that we only want to check if it is snowing or raining, and in one of the cases, we just want to print a simple sentence that says it is cold outside. Now, this is something that is quite possible with using some more logical operators that we did not see before. And as you could already maybe guess, then we can do this by an operator that says or. So if we go ahead and say something like the following, so we might want to create a variable that its name could be is_cold, and we could say here is snowing or is raining. Now, what this expression will end up doing, it will check if this is true or if this is true, and then in the conclusion it will return true or false even if one of them is true. So if we actually want to test this out, then we could say print is cold like that, and we could execute this program, and you can see that it gives true. Now, if I was to change the is raining to false, then as you could guess, then it will still return us true because is snowing is true and is raining is false. But if I go ahead and change this to false, then this will end up return us false because this was false and as well as this one. So the conclusion of these two will end up returning false. So it is very important to understand such a behavior as well. Now, some other logical operators that we have in Python are and not. So let's actually paste those and see what I am talking about. Okay, so we already covered the or operator, and as you can see, it says us returns true if one of the statements is true. And the AND logical operator is one of the operators that will return true if both statements are true. Now, when I say both, basically this could be for sure more than two. So you can concatenate as much as statements that you want, and you can concatenate it with only using the AND operator, and as well as you have the not operator, which is going to basically reverse the result of the statement that comes right after it. So let's see an example for each one of those. So let's go with is cold again, and I can say here is snowing and is raining like that. Now, I know that it might not make sense in real life, but just for testing reasons, I'm going to remain this code as it is, and I'm going to change both of those to true, and then this will end up return us true because this is true and as well as this one. Now, if I go ahead and change this to false, then this will end up return us false. Now, I also like to show you the reverser operator, and that will be by using the not keyword. So I can say something like the following. So I can delete everything from here, and I could say is_hot, and we could say not is snowing, something like the following. So if we actually end up printing this, then this will return us false. And the reason for that, it is because is snowing is true, and there comes the reverser of this entire expression, and then it returns it to false. Now, if I was to change this to false, then you could already guess that this will return us true because of the not operator. Okay, so actually those three are the very important logical operators that you can use in Python as well, and this will actually could help you to write more complex if statements, and there's actually no limit to the complexity that you can apply for your if statements in any programming language thanks to those three logical operators. So it is very important to understand that, and actually in my opinion it is very important to exercise some of the complexity in if statements by using and or not operators. So be sure to check my website to really practice this if you don't feel enough confident with the explanation that I have made in the last minutes. In this section, we are going to learn how we can store multiple values in Python in the most efficient way. Now, if you pay attention to what I have wrote till that point, basically I have 4 variables that are person 1, 2, 3, and 4. And now, as you can see, each one of those variables are responsible to store some name. But the point is, those variables are actually somehow connected to each other, but Python doesn't know that because it stores each variable in its own location in Python's memory. Well, to actually store this kind of information, we can do this with a more efficient way, and we can use Python lists. So the way that lists work in Python, basically you can go and open a square brackets and then you can assign it to a new variable name, and that could be something like people. So we could go ahead and say people equals to, and then we could open those square brackets, and inside of that Python expects for some values from us. So the values that we are going to provide here are going to be comma separated. So what that means, it means that if I'm going to type in one string here, then the next string that I'm going to type in is going to be separated with a comma, like the way that I have done now. And then now I can use this string to store my names. So I could say here Alan, and the second name could be Michael, and the other name could be John, like that, and as well as Ben, like the following. And now that I have a list with 4 names, I can basically get rid of those 4 variables, and the exact same information is now stored in one clean variable, and its type is list. Now, if I want to print this list, then I can basically go ahead and try to print that, and as you can see, the result down here will be just as expected. Now, before I go to my next explanation, if you come from another programming language, you might think that there is a rule that you should keep only one variable type in your lists. So what that means, it means that you are not allowed to store integers and strings in the same list. Now, basically, this is not a true statement when it comes to Python, because you are allowed to mix up between the variable types. So say that I want to store some random information inside a list. Then I can go ahead and start with some random string like that, and I can continue on with type in some numbers, and those could be integers and floats, and I could also store booleans in here, and Python won't throw me any error with doing something like this. So if I go ahead and print the values inside the random list, then you can see that it works quite well. So this means that we can include multiple variable types inside our lists. Alright, so now that we understood how lists work in Python, let's assume that we only want to print the first value of that list. Now, the way that we can do this is by using some default rules that are applied for each list in Python. So in each list, Python automatically will tag the values by its index. So if this is happen to be the first value inside our list, then Python will know to tag it with a number that will allow us to access this first value. And the way that this is going to work, Python is going to start counting from 0 till the end of the list, so that we could access only one single value inside our lists. So for that example, we could basically go inside the index of 0 for accessing this Alan value. So for this list, this could be the 0 index, like the following, and this is going to be the number 1 index, and that will be the number 2 index, and this is going to be the 3rd index. Now, I know that this might be confusing if you thought that the counting should start from 1, but this is actually how it works, and we have to get used to it. So now, the way that we can refer to values by their indexes is by easily going inside the list that we are calling, and try to use the square brackets right near of it and give it some value of index. So in here, if I say 0 and execute this program, then we should expect to see only the value of Alan. So now if we print this, then you can see that this is the exact result. So if we try this for 1, then we should see Michael. So this is very important to understand this behavior, because in some cases we might want to relate to a value inside the list by using its index number, and the way that is going to work is by using the square brackets right near the list's name, which is people in our case. Now, actually, one more point that I did not mention before, and this could be sometimes very useful as well. You might consider using the built-in len function to count the elements inside a list. So if you want to know how many values you have inside your list, then you can basically go ahead and print the len built-in function, and this expects for one piece of information in here, and the information that we are going to provide here is for sure the variable name of our list. And this should result in and print us 4, because we have 4 values inside that list, and this is exactly the result. So I just wanted to mention this as well, because this built-in method could be useful sometimes as well. Alright, so now that we understood the behavior of the built-in function len, let's actually move on to the next topic here. So let's say that we only want to access the last value inside our list. Now let's also assume that we don't know the length of our list and we somehow want to pull the last element. Now, as I mentioned earlier, Python starts to count the elements starting from the left to right. But you didn't know that it also counts the values starting from the right to left. So we already know that Python gives the tag of 0 to the first element when it counts from left. But it also knows how to count from right to left. So the way that it does that is by starting to count from -1. So if we go ahead and type in here -1, it will always pull the last element from our list. So if we actually go ahead and print this, then we will end up by receiving Ben, because this is the last element inside our list. Now, if we were to change this to -2, then the result will be just as expected and we will see John. And the counting goes till -4. And actually the most important case in here to understand is that you can access your last element inside your list without really knowing the length of your list. So if you always refer to -1 index, then you should be fine and access the last element of your list. And this is also something very useful in Python. So let me just fix the ordering in here. So I will basically put this in here and I will locate this in here. So now we can really understand that we have counting from left to right, and we also have from right to left, and we can use negative numbers for accessing the elements with this way. Alright, so one more important point to know about indexing in lists in general is that you can give it a range of indexes. So say that you only want to access the first 2 elements no matter in which list you work with, then you can basically refer to that by using the colon sign and then specify the next index number that you want to see included when you refer to a specific index. Now maybe you have expected to type in here 1 and basically receive the first 2 elements of that list. But basically when you go with this approach, it will only pull the first element because the last number is always not included when you want to pull a range of elements from a list. So say that you want to pull the index of 0 and index of 1, then you should type in here 2, because as I said earlier, the last number is not included. So this will be responsible to pull the elements of Alan and Michael. And if we were to say 0 to 3, then this will end up by pulling the first 3 elements, because the 3 index is not going to be included when we type such a code. Now there are some more complex ways to define the indexing strategy in here. So if you want to pull all the values except the first one, then you might go ahead and say something like the following. So say that I want to start counting from the first index, I mean the index number 1, and then I want to pull every value that comes after it. And for this I could basically specify the colon sign and leave it as it is. So now if I print that line, then you can see that it results in to pull all the values except Alan. And it will not matter if I add here some more name like Jim and like Ross, something like that, then it will end up pulling all the elements from that list, just not the first one, because this is what this indexing is responsible for. Now say that I only want to pull the first 2 elements, then this is going to be quite similar to 0 colon 2, but basically we can omit the 0 from here and this will be responsible to the same exact result. So as you can see, this is responsible to pull in the first 2 elements. So there are a lot of ways that you can play around with indexing in lists, but basically just remember the examples that I gave here, and if you want to catch up with the examples that I showed here, then for sure you can go to the code itself from GitHub and see the examples from there. Okay, so now I will go over some of the useful methods that we have in lists. Now, until that point, we understood the idea of lists in general, but we did not learn about the methods that you can use within a single list that you declare. So, for example, we have a method that will allow us to add an element to a list, and its name is append. So, if I was to go ahead and say people.append, and then I will call this method like that, then this method will go ahead and add some additional element to our list. Now, till that point, we did not saw methods that are expecting from some additional information from us. So some of the methods in Python are actually going to force us to put in some argument. And the argument is going to be like an additional info to that method to execute successfully. So in that case, it totally makes sense to provide in some additional information here that will specify what element we want to add to that people list. So if I was to go ahead and say, for example, Jim in here, and I will execute now print people, and now I can execute this entire file, then you can see down here that our list is now including the element of Jim. So what that means, it means that this append method will end up adding some elements to our list. Now we have some more useful methods in here that might force us to receive some additional information. So let me delete this from here quickly and go over some other methods. So we have the remove, which is the exact opposite action from appending to a list. So we could delete, for example, Alan, Michael, and whatever element we'd like that we know that is inside that list. And we can also remove an element by specifying its index. So if we were to say down here people.pop, and we will end up by giving the 0 as an information in here, then this will go ahead and remove Alan because this is the element in index of 0. And we can also use the method of sort down here, as you can see, and this will allow you to sort your elements alphabetically if your list includes a list of strings, and if you were to have a list with integers or floats or something that is numeric, then it will end up sorting from the lowest number to the higher one. Okay, so let's actually give some examples of all the methods here. So let me minimize all the comments and show you some examples. So we saw what the append method is about, so I will not show that, but I will go over the remove and I will show you what it will do if we do remove Alan. And then I will go ahead and print that list. And then you can see that we see all the elements but not Alan. Now, if we were to add here something weird that is not actually existing in the list, then we will end up by receiving error that says us for list.remove with the argument of x, x not in list. So what that means? It means that you cannot remove an element that is not existing inside a list, and it totally makes sense to receive an error about this. Now we can also use the pop method with index of 0, and this will also go ahead and delete the 0 element, and we can do the same for 3, for example, and then you can see that Ben is disappeared. Now I want you to take a look for something very critical in here. Now if we were to remove the index of 1, then it will lead us to a situation where the indexes are changing. So what that means? It means that we have to be very careful with the pop method, because it might change the ordering of the indexes totally, and the remove function will be responsible for that as well. So make sure that you don't screw up your list when you use remove or pop methods. And we also have the sort. Now the sort method, as you could guess, is not going to receive any additional arguments, so I'm just going to call it as it is. So if we were to call this sort method and go ahead and print this up, then you can see that the ordering now has been changed, because now Ben is not the last element. Besides, you see it over here because it sorts it alphabetically. Now I also like to show you an example with numbers of that case. So let me create a list of numbers very quick. So I will say 7 like that, and 0, let's actually write 5, and then 2, and then we will change this to numbers, and we will print the numbers list. And now if I go ahead and execute that out, then you can see that we receive this list of integers sorted as expected. Alright, so now that we understood a little bit about lists, let's try to write a program that will pick a name from this list randomly. Now, by saying randomly, we might be confused to really understand how we can pick a random element from a list. And that is exactly why I said in here that we might need to use some external libraries to complete such a task. So it is a great idea to search for a library, in this case, that will help you to pick a random element from a list. And remember that the moment that you pick up this random element from a list, then we should also go ahead and delete the selected element from this list. And by the end of this program, we should just display a nice print message with a formatted string that will explain about the chosen element, and in that case that will be a name among the list of people. Alright, so it could be great if you try this by your own first, so this could be a challenging exercise for you, and I will provide the solution just in a minute. Alright, so now to the solution. So first, let me move this list to down here so I can minimize the comments like that. Okay, so there's actually no way to pick a random element from a list unless you go ahead and use an external library. Now, the way that you can use an external library, like we learned in the previous sessions, is by using the import keyword. Now, the library that supports some random actions is actually called random. So I can say import random like that. Now, there might be some other libraries that supports the same thing, like picking an element from a list, but basically this library is also good to go with. Okay, so we could say here something like the following. So as you remember, when I explained about libraries, we can access the functions inside the libraries by referring to library's name and then pressing the dot sign. And as you can see, all the libraries, all the functions are available within this library. And actually, the choice function will help us to really pick an element from a list randomly. And if we were to pass here as an information the variable of people, then this will go ahead and pick up a random element from a list. So now it is a perfect idea to assign this entire code snippet to a variable. So we could say chosen person equals to, and then save it like that. Now if we want to verify ourselves here for a minute, then we can easily go ahead and say print chosen person, just to see what this code will be responsible to show us. So now we can execute our program. Then you can see that we receive here Ben, and that means that it randomly picked this element. But if we were to execute this one more time, you can see that it picked Ben again. So let's make it to pick something else. And now you can see that it ended up by printing us John. Now we can continue on by executing this a couple of times. Then you can see that it always picks Alan right now. So let's make it to pick Michael. And okay, so you can see that this is really choosing a random element from a list and it works okay. So now we could go ahead and delete the randomly chosen person from this people list. So to do that, we can use the remove method. So we can say people.remove and we can basically remove the chosen person. And now that I have done this, then I can go with the print built-in function and really print a formatted string about the chosen person. So we can say the chosen person is, and we can refer to that chosen person variable like that. Now, if we want to verify ourselves that the element has been actually deleted from the list, then we could try to print the length of this list. So it will be as easy as using the built-in len function, and we can pass in as the information people like that. Now this should result in to print us 3. So to make it a little bit nicer, then we can actually turn this to a formatted string as well. So we could cut this expression from here. So I will press Ctrl X and I will say formatted string again, and I will write in the length of this list. Actually, let's change this to people, and we can refer to the exact code snippet that we had previously, which is len people. Now I can go ahead and execute this program, and you can see that the chosen person is Ben, and then we receive the length of people list is 3. So that means that we have done a great job completing this task. So I hope you understood each part of this solution. Let me know if it was a clear explanation for you, and also feel free to share your code so I can read your solutions in the comment section. Now, those external libraries of Python are what makes the language so fun to learn. So if you want to extend your Python knowledge, then I have a lot of videos talking about different libraries and frameworks, and they could help you to write exciting projects like web scraping projects, web applications, and graphical interfaces. And all of those videos are free and always available on my channel, so make sure to take a look. In this section, we are going to learn about tuples. So tuple is a new variable type that we should learn in Python programming language, exactly like strings, integers, or lists. But basically, a lot of programmers like to compare tuples to lists. It is because the tuple is doing the exact same job like the list does. So tuple could also include multiple information like the lists. So now we can ask ourselves, what is the main difference between lists to tuples? So a tuple is actually immutable, and what that means? It means that once you declare a tuple, say that you declare a tuple with 2 elements, you are not allowed to change its element throughout the execution of the program. So let's see an example of that in action. So I'm going to type in here the exact same list like we had previously. So I will say Alan, and I will also say Ben, like that. So we have here a list with 2 elements. And let me try to use some of the methods that we learned in the previous section. So that will be, for example, people.remove, and we could remove Alan from the list. And if we go ahead and print the people, there are not going to be any surprises, because we are only going to see Ben since we removed Alan. Now I'm going to turn these people to being a tuple, so it will only require from us to change those square brackets to being regular brackets like that. And as you pay attention, both the opening and the closure of these brackets has been changed. And to actually document this up, let me write a comment here like the following. So a list will be created with a square bracket, and a tuple will be created with just regular parentheses. Now you can also pay attention that whenever we change this to being a tuple, this remove method is throwing us some error. And the reason that it happens again, it is because you are not allowed to change tuples elements right after you declare it. So if we were to execute this program, for example, then we would receive an error that says us tuple object has no attribute remove, and that means that we are not allowed to execute the remove method on our tuples. And the same approach will go if I was to change that to append like that. I will still end up by receiving some errors about how I cannot change tuples elements right after I declare it. So it is important to remember the difference between a tuple to a list, and once you create a tuple, you are not allowed to change its elements at all. Now in this stage you can ask yourself, why do we need a total different type of variable that will be the same as list but an immutable version of it? Well, the reason for this, it is because sometimes you want to create values that are absolute values that are never going to change throughout the execution of your program. So for example, if you think about it, we have in life a lot of absolute values that are never going to change. For example, the months of the year or the days throughout the week. So say that you want to develop a weather application and you want to display some information about each day, then it makes sense to maintain an information about each day of the week. So for this purpose, you might go ahead and use a tuple like that that will include each of the days in the week. So it could be Monday, Tuesday, and Wednesday, and so on. So let me write here Wednesday. Great. So this is the purpose of tuple, and this is actually one of the reasons that I could think when we should use tuples. So just to show you here, if I was to say here print days, then you could see that it works great. And we can also index each element in a tuple exactly like with the lists. So if I was to copy and paste this two times just to show you, then we could access each element by its index number. So that will be 0, and this will be 1, and that might be 2, like the following. And now if we execute this program, then you can see that the result is just as expected. So in this case, this is quite similar to list because we are allowed to access the information inside the tuple, but we are not allowed to edit the information inside a tuple. Now, for sure, there are going to be some more use cases for the tuple that we are not going to learn in this stage. But for example, there might be some built-in functions that will result in to return us tuples. And so this will mean that we have to know and understand how we should work with this type of variable. So this is why it is important to know about this type of variable, although it might be sometimes not commonly used. Okay, so now that we finished working with lists, let's jump on to our next type of variable. Now in the following situation, I have 4 variables and I also print them. So I start with friend name, age, gender, and weight. Now as you can pay attention, there is something in that file that I quite repeat myself over and over again. So if you can pay attention, then I always use the prefix of friend, and that is because I am describing some person which is happen to be my friend, and I do give it as a variable name like friend name because I want to describe his name, and as well as I'm doing the same thing with age, gender, and weight. Now you can also see that I have to execute the print built-in function 4 times to really receive each piece of information that I want about my friend. But it could have been a lot nicer and quicker if we could somehow store all the information about this friend under only one variable. And so we can actually do this by using Python dictionaries. Now Python dictionaries exists to solve this exact problem where I have to repeat the description of friend about each type of variable if we will only work with regular variables like we have learned till that point. So dictionaries will allow us to store multiple key value pairs, and then it will be a lot easier and quicker to declare some attributes about this friend that I am trying to describe here. So let's actually see an example of how we can work with dictionaries. Okay, so let me delete all the print lines from here. Now I'm going to stick with this example so you could have a comparison to what I'm going to write now to what we wrote when we started the session about dictionaries. Okay, so I will start by creating a variable that I will name it friend. And to actually create a dictionary, we have to use the curly brackets like that. Now, this is the first time that we see curly brackets that is not used inside formatted strings, so just remember that it can also be extremely useful when you want to basically create dictionaries. Now I can also press enter in here, and you don't have to worry too much if you don't use the same lines when you work with one dictionary, because Python will support that. Okay, so to start creating some key value pairs under this dictionary variable, we can basically specify the exact same attributes, and then we could include the keys within a string, and our value could be whatever we'd like to. So in the left side we will always have the keys, and in the right side we will have our values, which could be any type of variable that we like to. So it could be booleans, integers, floats, and strings. So let me create a key that will name it name, and I will make that to be equal to Mike. And say that you want to add some more keys and values, then you can go ahead and specify a comma here and press enter again. Now the enter is not actually a mandatory step. Basically I'm doing it only for comfort reasons, and it makes the dictionary to look a lot nicer when you separate each key and value pair in different lines. So I will go ahead and say age and colon sign, and we can do 25. And we can do the exact same thing with gender. Actually, in that case, I'd like to show you the boolean case, so I can just create it is_male equals to true, like this. And we can also go ahead and say weight colon sign 64.5, like that. Now again, I want you to pay attention how I specify a colon and not equal sign, because this is how a key is attached to a value inside a dictionary. Okay, so now that we have done this, then the only thing that I have to do now is printing the friend variable, and then Python will go ahead and print each key value pair in the console. So if we were to execute this program, then you can see that the information is right there just as expected. And again, this is much quicker than the previous approach that we just declared a lot of variables. So now we can delete everything from here and actually continue on about learning some more best practices about dictionaries. Okay, so before we see the next topic, I just wanted to add this description up top that explains in a few sentences what are dictionaries. So like we said, it allows us to store multiple key value pairs under a variable name, and it is extremely useful to store information, as you could already see that. Okay, so as you can see, we are still working with the same dictionary, and let's actually see some more useful stuff about dictionaries that could really help you to write some more complex programs. Okay, so say that you are not interested in all the key and value pairs, specifically in that case. So let's say that you only want to see your friend's name in whatever program you write. So the way that you can achieve this one will be by using the square brackets right near when you call the dictionary. So it will be something like friend, and we can say square brackets like that. Now I know that this might be something that is confusing for you, because we used to see those square brackets when we wanted to pull an element with specifying its index. But actually, when it comes to dictionaries, unlike lists, in that case you only want to specify the key name, and then this will end up with pulling the value of the key that you specify. So if we were to print this exact statement in here, then this entire line in here should return us Mike. So if we actually execute this program, then you can see that this is the exact result. So this is one way that you can see the value by specifying its key name. But another way that we can see the value of some key would be by using a method that its name is get. So we could delete this from here, and actually let me create a duplication of this line. So we could change this to .get like that. And as I said earlier throughout this tutorial, some methods are going to expect for some additional information, like in that case. So if we will say here name, then it will end up by pulling the mic value as well, because this is the value that we have in here. Now you might ask yourself, which one should I use and why we have two methods to do the same task? Now the reason for this one is that this one will end up by returning you an error if you mismatch the key name. And mismatching means that you specified a key name that is not existing inside this dictionary. So if we were to say here is female and execute this program, so let me actually comment this out, and I will replace the key name in here and test this later as well. So now let me execute only the line that is trying to access the value by square brackets. Now if we execute this, then you can see that it will end up by returning us an error, and this will break the entire execution. But if we were to uncomment this line and comment this line for a minute and see the results of that, then you can see that it does not actually returns an error, but it returns none. So the difference between those two ways is that this one will crash your program if it sees that you mismatched your key name, but this one will only try to give you the value back of the key that you specified, but if it does not find it, then it will just return you none. Now I know that we did not talk about the none too much before, but basically this is a unique value of its kind, and what it means that this is basically just nothing. There is no information inside of that, and this is why its name is none. And this is a very specific value type that we have in most of the programming languages out there. Sometimes it might be null, but in Python it's pronounced as none. Alright, so let's see some more examples about dictionaries in Python. Now I'm going to go over two methods that you can already guess what they are going to do, because their name are keys and values. Now before I actually show you what those methods will do, I'm going to be very honest with you and say that there are a lot of more methods rather than just those two. But I don't think we have too much time to cover all the methods, because some of them are doing some more complex stuff that I'd probably not like to go over them at this point. Okay, so when we want to pull all the keys from a dictionary, then we can call the keys method. Now the way that this is going to work is by easily saying friend.keys like that. Now to actually see all the keys, I might wrap this statement with the built-in print function. This will result in to pull all the keys from that dictionary. But if we take a closer look in here, then you can see that we see some other statement that says us dict_keys. And now we are asking ourselves, what is that type of variable? Because this is not absolutely a list, right? Because it says us dict_keys. Now this is actually some other object that is basically called dict_keys, but we might want to see this keys list in a real list object. So if you remember from the previous sessions throughout this tutorial, I talked a lot of times about how you can convert between different types of variables, and this is actually the exact thing that we have to do here. So if we want to see the keys as a pure list like we have learned in the previous session, then we can go and say list and use the built-in function that will really allow us to see this entire statement in a list version. So now if we were to execute this program, then you can see that we receive a list with name, age, is_male, and weight. And to really prove you that this is a list, then I can go right after this statement here and call the 0 index like that. And now if we were to print this, then you can see that it returns us name just as expected. Now let me do a few of Ctrl Z's in here so we can undo the latest steps that we have done, like that. Okay, so the same thing will go for values. So say that you only want to perform some specific action with values, then you can change your method to be .values like that. And this will do the exact same thing like it was with the .keys method. And you can see down here that it gives us all the values. And again, you can convert this to a list and access a specific value if you'd like to. And really, you can perform any action that you'd like to if you got all the values as a list. Alright, so now that we understood a lot of variable types that are existing in Python rather than just the basic ones like strings, integers and stuff like that, now I want to talk about one of the most useful built-in functions in Python, in my opinion, that might help you to create some great programs in the future. Okay, so the built-in function that I'm going to talk about will be the range built-in function. Now, what range built-in function will do? It will basically accept some additional information from us, and it will help you to generate some numbers between a given range of numbers. So let's say that we want to generate a list with all the integers between 1 to 100. Now, doing this hard-coded could take a lot of time, and we probably want to avoid that. And basically, besides that, the only thing that we have to do in that case is calling this range built-in function and only passing in the argument of 100. And now we can assign it to a new variable. Let's call it numbers, like that. And now if we want to print this out, then we can say print numbers, like that. Now the minute that I execute this program, then we might see this output. So this basically says you that the numbers variable is a type of range object that is starting from 0 and ends at 100. Now actually, it might be a wonderful idea to try to convert this numbers variable to a list, because this will allow us to see all the numbers, basically integers, that are between 0 to 100. Because if we pay attention, this range built-in function will allow us only to see the output like the following. And if we interested to see all the numbers, all the actual integers, then we have to go ahead and convert this to a list, like we did previously in one of our sessions when we talked about dictionaries. So we can go here and say list and wrap this up like the following. Now if we were to print this out, then you can see that I got all the numbers, integers, sorry for saying numbers all the time, between 0 to 100. But now you can see that the list finishes at 99. So again, sometimes the number that you provide in as an argument when you work with numbers in Python is not going to be included. And I said this number of times when we worked with range indexes, when I explained about the range indexing in list topic. So this is why it is important to remember that. So this will be responsible to generate all the integers between 0 to 100. And we can do the same like with 10, and you just have to remember that the number you specify is not included. So this is why we see all the integers from 0 to 9. Now let's say that we don't want to start with 0, and we want to receive all the integers from 5 to 10. And by saying 10, I mean from 5 to 9. So you can specify an additional argument in here right near the 10, but from the left side, and we can say 5 like that. Okay, so now if we run this code, then we will end up with receiving all the integers from 5 to 10, but 10 will not be included. And if we actually want to receive only 5, 7, and 9, so we kind of interested to have the step in here, and the step is by 2. Then we can also specify that. Now the place that I will specify this will be near the 10 number, so we can say here 2, and the code, like the following, will be responsible to start a list by the number of 5 and will try to jump itself to 10, but since we specified by the end of this range function the number of 2, then it will end up by generating all the numbers, but the jump step will be 2, so this is why we see this output. Alright, so in this topic I want to focus on something that is probably the most useful thing in any programming language that will allow us to save a lot of time. So in this list I have 3 elements like we saw this previously, and let's assume that I want to have a print line that is going to describe a sentence like Alan is my friend and Ben is my friend and as well as John is my friend. So to actually achieve something like this, then we can go with those 3 lines until what we have learned until now. So we have a formatted string in here that calls the 0 index of this list and says is my friend. So if we were to run this program, then you can guess that we are going to receive Alan, Ben, John is my friend 3 times. But as you can see, I repeat myself 3 times unnecessarily. Now to actually overcome this, we use in any programming languages something that is called for loops. And basically for loops could allow you to execute some action multiple times. Now let's actually see how for loops works in Python. So to actually have a comparison between those 3 lines of code to what I'm going to write now, let's leave those lines in here and move on to writing some code in here. Now I'll be honest with you, but there's a great chance that the code that I'm going to type in here might be very confusing in the first look, but I promise that we will do a short breakdown and really understand every important concept about for loops. Okay, so to basically achieve the same behavior like we had in here and to efficient our program, the only thing that we will have to do here is using the built-in keyword that is called for. So this is basically preparing our for loop, and then right after it we have to pick up a variable name that we'd like to create that is going to relate for each element during the iteration. So I can pick here a variable name like friend, and the friend variable totally makes sense because I'm iterating over a list of friends. So now that I have done this, then basically I have to specify what is the variable that I am going to apply the for loop on. And in our case, it will be the friends list. So I will continue by saying in friends like that. And as soon as I completed this, then I have to add the colon sign, and the second that I will press enter, then it means that the code that I'm going to execute here is going to be repeated 3 times. And you might ask yourself why specifically 3 times, and the reason for that, it is because we have 3 elements inside our list. Now before we actually test the for loop, let me please comment out those lines from here, so it will make a lot of sense to not confuse us. Okay, so now I can say here something like print, and I could just print the friend variable. And remember that the friend variable is created as a variable that is going to relate for each element. So at the first stage, it will relate to Alan, and then Ben, and then right after it, John. And if we want to see this in action, then let's execute this program. Then you can see that first we receive Alan, and then we receive Ben, and right after it we receive John. Now let's do a short breakdown of what happened in here, just to explain the background actions. So first, we started to initialize our for loop, and as we said earlier, the action is going to be repeated 3 times because we iterate over the friends list, and there are 3 elements inside this list. So we went ahead and we refer to the variable that we access when we iterate, which is the friend that we have created in here. And since the first element inside this list is Alan, then it went ahead and printed Alan. Now, right after it, Python saw that there are no more lines of code to execute within the for loop. So if I scroll this down a bit, then you can see that the only code that is inside the for loop is print friend. So this is why Python jumped back to the for friend in friends. And then the next time the iteration is going to be over the ban element, because the iteration over the first element has been completed. And right after it, the same exact action will be repeated for the last element, which is John. So this is the actions that are happening in the background when you launch a for loop in Python. Okay, so before we move on to the next topic, let's actually convert this program to be the same as we tried to do in the previous example, like in here. So now we know that we iterate over each element inside this list, then we can easily say print and we can call the F for formatted string. And now we can only relate to the friend variable, because this is actually the variable that will be iterated when I iterate over each element. And then I can say here is my friend, and that should be enough. So if I execute this program, then you can see that the output is just as expected. Now, another thing that is quite beautiful with the for loop approach is that if one day you decide to add 10 more friends to that list, then this code will totally support that, and this will not, because this will mean that you have to copy and paste yourself over and over, and this is something that you always look to avoid in programming. So let's actually add some more names in here. So we could say Michael, and we could also say Jim, like that. Now, if I'm going to again execute this program, then you can see that the output is just as expected, because those two lines will be responsible to iterate over each element inside a list. Alright everyone, so now I'd like to introduce an exercise that I'd like you to take a look at. So we want to write a program that will check if the best friend is inside the list of friends, which is here. Now basically I just want to write a code that will check if the best friend value is inside that list, and if so, we'd like to throw a special message. Now I'd like you to first try this by yourself, and if you like to, you can pause the video and I will provide the solution just in a second. Great, so let's think how we can break down this question and try to solve it with writing some lines of code. So we understand that we have to somehow identify if the best friend is inside the friends list. Now there are multiple ways to actually complete this task. So let's actually go forward and try to think on one way that you can do this. So I'm going to actually say down here solution 1, and I will provide two solutions that are going to be quite different from each other. So let's start with the first one. Now the first thing that you might think here, okay, so now I got a string and I have to check if it is inside a string, and I already know that we have a built-in keyword that its name is in. So what I could do is basically check if the best friend is a value inside a friends list. So the way that we can do this is by asking with an if statement something like the following. So if best underscore friend in, and then we could say friends. And now, as long as this condition returns true, we'd like to print a special message like it is requested in here. So we could say inside the indentation, print Alan is in the list of friends, like that. Now for sure, excuse me about that, you don't want to write Alan hard-coded, so you can fix that by calling the formatted string and actually to refer to the value of the best friend variable, like that. And that will be one way to solve this. So if I run this program, then you can see that the result is quite perfect. Now, one more way that we can solve this is to start using for loop and then search inside each element if it matches the best friend value. Now, here's the actual reason that I actually stopped introducing new topics in this tutorial and to really explain some important topic in here. You can actually mix up between different logics when it comes to programming. So you are allowed to mix for loops and then use if statements inside of it. So this is actually why I am doing this exact exercise, because I remember myself when I started to program, I did not quite understand that. So this is why it is very important to me to say that in this stage. So what we could do here is basically start an iteration like the following. So we could use the for loop and say for friend in friends like that. Now, what will happen in this stage is that I will iterate over each element one by one, and I could check each time that I iterate over an element if it matches the string of best friend. So we could say if friend equals to best friend like that. And if we actually going to hit this conditional one time, then we can say here print, and then we can use the formatted string and we can say best friend is inside the list like that. So now if we go ahead and execute this program, then you can see that the result is also perfect like the first solution. Now you might ask yourself, what is the better approach? Actually, the first one is a lot shorter and a lot quicker, but this actual example will really explain you that you can use for loops inside if statements and you can use if statements inside for loops and so on. Alright, so now that we understood a little bit about for loops and if statements, now we should understand how we can solve programming problems when we write some projects. Now, in my opinion, the more lines of code that we write as programmers, then there are higher chances that we will end up with having some bug or two in our program. And basically, a bug is a problem with our program that is causing our program to not behave as expected. So to actually analyze and to solve the bugs, then we will have to use some utilities of the IDE that we work with. And actually PyCharm has a very good utility that will help us to debug our programs. Now each IDE will have its own tools to debug your program, and in my opinion PyCharm has some great debugging tools that will help you to solve your problems when you come up with some complex project. So let's see how we can debug our programs with PyCharm. So to actually show an example of that, then I'm going to paste back the exact program that we wrote in the previous section. Now that doesn't mean that we actually have a problem with this project, but I just want to show you the basic ideas of how you can debug your projects. So in here, if you remember, we have the list of friends and we have this best friend variable, and basically we use a for loop to iterate over each friend. And then we go and say if friend equals the best friend, and then the minute that we have a match, which means that this statement returns true, then we just enter inside here and we say best friend is inside the list. Okay, so we said earlier that the debugging is actually a great way to identify your problems. Now, debugging could be also very useful when you want to simulate the execution of your program step by step. So, for example, when you include for loops in your program, you don't really see what is going on behind the scenes, because the for loop is responsible to execute some action multiple times. And in our case, it is responsible to execute it 5 times because we have 5 items in our list, but we don't have actually a way to see what is going on in behind the scenes. So debugging could be very useful for this exact case as well. It can help you to break down the execution of your entire program and to see each step that Python completes line by line behind the scenes. So to actually show you that, then I'm going to use the debugging tool to really see what the for loop does step by step. So actually the greatest way to start debugging for loops it is to choose this line as being a breakpoint line. Now, when you go ahead and choose a breakpoint line, it means that you basically stop the entire execution of the program as it's expected, and you go ahead and you control each line execution by yourself. So let's actually see this in action and you will understand this a lot better. So I'm going to left click right where the number of line is. So I'm going to click here, and then you can see that it marked this line as a breakpoint, and you can identify this because this whole line is with red background. Okay, so I'm going to go here to run, and I'm going to use debug 1. So pay attention that I don't click on run and I click on debug. So the second that I have done this, then you can see that we entered into a special mode that is so called as debugging mode. Now you can see down here that we have some control panel to perform some actions, and in that area you can see that we see all the variables and their values at this stage of the program. So it is a nice feature because now you can be aware what is the value of each of your variables. So you can see that I can click here and I actually have full access to what is going on inside the friends list. So it is very comfortable and a great tool that you can use. So if you want to execute the next line from this stage, because now actually the program has quite been frozen in here, then you can press F8. Now the second that you execute F8, then you can see that the for loop here has been started. And you can see that it says us that the friend variable is equal to Alan, and it totally makes sense because this is the first element of our list. Now if I'm going to use F8 again, then you can see that Python entered inside this line because this conditional returned true because Alan is really equal to Alan. Now if I'm going to press F8 in here again, then you can see that the program is back again at the 7th line, and now I can press F8 again, and you can see that the value of friend has been changed to Ben because now the iterated variable has been changed from being the first element to second element, and I can go ahead and press F8 as much times as I want until I reach the last element of our list, and then the for loop will stop the execution like that. So actually this is a very great way to analyze problems and as well as seeing the behind the scenes actions of the Python programming. And as you saw here, it will help you to see step by step what Python does when it executes some program. Now the debugging tool that PyCharm has in here is actually more advanced rather than what I showed you in the last minutes, but for sure we don't have time to cover everything. So if you want to know more about debugging, then I might have created a video about debugging more deeply, so make sure to check my channel out for this specific video. Alright, so the next topic that I want to show here is somehow related to for loops. So to actually show you what I want to teach in that stage, let me debug this program again. So I'm going to click on debug. And the second that I have completed this, then I'm going to press here F8 a couple of times until I reach friend equals to a different value than Alan. Okay, so now we have friend equals to Ben. Now, if you remember, I said that the purpose of this entire program is to check if our best friend is in the friends list. So actually, if we find the best friend inside this list, then we might ask ourselves, why do we need to continue executing this program? Because we were able to reach our goal of finding our best friend. So this means that we are executing some lines of code and the execution is actually pointless because we already found the Alan inside the list of friends. So to actually overcome of something like this, then we use something that is called break statement. And whenever you use the break statement in your programs, then it will immediately get out of the iteration of whatever for loop you declared the break statement. So let's see this in action. So let me stop the debugging in here and actually close this out again. And to actually simulate you that, then I'm going to say here else like that, and I will type in here print this is, and I will say here friend like that. Now let me change this to being a formatted string and we are good to go. So now if I execute this program again without debugging, then you can see that we receive this is Ben, John, Michael and Jim. But again, we said that we don't need this information because we already found Alan. So what we can do is right after we print this sentence, then we can use break. So if we actually execute this program now, then you can see that we only receive Alan is inside the list. Now it is very important to understand that the break statement does not quit the entire Python program, but it only gets out of the for loop. So to actually simulate you that, then let me please go out of the for loop in here. So I will indent out 2 times and I will say exactly here print I am just a random line after the for loop like that. Now the second that I have done this, then let's see the results of this program now. So I will execute our program. Then you can see that at first we receive Alan is inside the list, and since this line has been reached, then the break statement is going to execute, and then this means now that the program is out of the for loop, and now it went ahead and executed the rest of the program as expected. So again, it is important to understand that the break statement will only quit from the associated for loop and not totally from the Python program. Alright, so now I want to show you one more exercise that is related again to for loops, but this is a very important topic to understand as well. So say that we have a budget of $100 and we also have one more variable that says sandwich underscore price is equal to 5. Now I want to write a program that will simulate a situation where you buy 20 sandwiches. So this means that we have to decrease the amount of this value by 5 every time. So what this will mean? This will mean that this value will be 95, 90, 85 and so on until we reach 0, of course. So I have to be honest here, I did not teach how you can override variables value, but I'd like you to have a look and try to solve this by your own. And in my opinion, if you use for loops as expected, then you should be good to go and really to write such a program. So try to do this again by your own and I will provide the solution. Alright, so we said that we should somehow simulate that we purchased a sandwich 20 times. So it is obvious that we have to start somehow with a for loop. But since we don't have anything special that we should use the iteration on, then we can basically use the range built-in function and we can simulate the exact same action 20 times. And if you remember, range is responsible to count all the numbers starting from 0 till the reached number. So that is why we can say something like for s or any variable that you like to in range like that. Now the minute that you have completed this, then before we actually take some action, let's use print and say something like hello like that and execute our program. Then you can see that we receive hello 20 times. So as you can see, you can use the range built-in function to use for loops. Okay, so now that we understood this, then let's actually try to write the actual program. Now in Python, we have something that is called value increment and value decrement. Basically, this means that you can override your variable's value throughout an execution of a program. Now I know that I did not cover this topic yet, so if you done the program with a totally different approach, that is totally fine. But if you were able to figure out by searching how you can override variables value in Google, then that is perfectly fine as well. Okay, so let's see how we can do that. So I'm going to call the budget variable here, and I'm going to override its value. So that will be by saying budget equals to budget minus sandwich price. And by writing this line in here, then what this will do, it will go and declare the budget variable again, but I'm referring to what the budget value is right now, and right now its value is 100. So it will go and decrease its value by 5. So in the next iteration the budget will be actually set for 95, because now this line was executed and I recreated, meaning override the value of 100 to being 95. So let's see this in action. So I'm going to leave this line in here, but above that I'm going to say you bought a sandwich like that. Okay, so now that we have completed this, we should somehow verify that the budget variable is actually overridden 20 times. So the way that you can do that is printing its value after the for loop. So this is why I indented out, and I can say here print budget like the following. Now if I go ahead and execute our program, then you can see that we receive this output 20 times. And further than that, we see that we receive the value of 0. So this means that our program worked successfully and we were able to override the value of budget. Now you can also verify this by yourself using the debugging utilities that we have covered in the previous sections. Okay, so now that we understood how we can decrease some value, let's see how we can efficient this entire program. Now there is an actual equal statement to what I have wrote in here that we did not see before. So writing this line and writing something like budget minus equals sandwich price is actually equivalent to this one. So this and this statement are quite the same. So let me delete that. And let me explain what this logic means here. So when Python sees those two signs combined, then it is going to decrease the value of the declared variable by this value. So if I go ahead and execute this program, then you can see that the result is quite the same. So this is something that is called Python decrement, and the same approach will go if you want to use increment for some value. But in our case, we want to simulate a situation where I buy something, so it makes sense to decrease the entire budget of the person that purchased that sandwich. Okay, so this is a way that you can use decrement, and it is very efficient when you launch some for loops in your programs, and in the future we are going to see the exact opposite action as well. So this will be by basically saying something like budget plus equals, and let's say 10 for example. So that will be Python increment like that. And again, we are going to use both of those a lot when we develop some projects. In this section, we are going to focus on another type of loops that we have in any programming language. And this kind of loop is actually dependent whether if a statement returns true or false. So say that you want to keep some execution, keep on going until some statement returns true. So this is something that you can achieve by using while loops. So while loops will allow you to have an execution of your code block till the point that this statement is actually true. Alright, so the best option to show an example of that would be by using the exact same program with a total different approach that we have done in the previous section. So let me only put here the variables that we used to solve the latest challenge, and let me write a solution that will apply the same logic, but this time we will use while loops. So I can say here while like that, and whenever I specify this keyword, then Python expects for a conditional right after it. So I can say here budget greater than 0 like that. Now the second that I have done this, then the entire code block within the indentation is going to be executed continuously until this condition is not true. So now it is true, but when we reach budget equals to 0, then 0 is not greater than 0, then we will get out of the while loop. So let's see this in action. So I will say here, budget minus equals to sandwich price like we have done previously, and I will also add here the print line that will say you bought a sandwich. So there is nothing really different with the actual logic implementation of the program. Besides, we use some different tools to achieve the exact same task. So now if I execute the same program, let's before print here budget like that, and now I can allow myself to run this, and if I run this program, then you can see that the behavior is the exact same behavior like we had previously. So this means that you can also solve pretty much each problem with while loops. And this is actually a greater implementation because now your program is more dynamic than what we have done previously. Because now you can change the budget to being 200 and run your program, and you can see that we received the you bought a sandwich 40 times, and we can do the same approach by changing our budget to 1000, and then we will be able to purchase 200 sandwiches. So you can see that sometimes using while loops could help us to be more dynamic with our programs, and it is very important to understand that. Now, for those of you that did not quite understand how while loop really works, then I can basically simulate it with debugging our program. So let me decrease the budget in here so we will have a shorter execution like 30. And let me put here a breakpoint, which we already know how to do that with the debugging section that I have covered. So let me run debug like the following and see everything in action. So here, as you can see, the budget is currently equal to 30 if I look in the bottom section, and the sandwich price is 5, and nothing is surprising about that. So if I use here F8, then you can see that I entered the print line, and I will also enter the budget minus equals sandwich price. And you can follow the values also from this line and as well as from this line. So if I press F8 again, then you can see that the budget has been changed to 25. So since we use the while loop in here, then Python asks if the budget is greater than 0, and it is, so we can enter this while loop. So I'm going to repeat that, and in 20 it is going to be applied once again. So in 15 once again, and in 10 once again, and in 5 once again. And then when I reach budget equals to 0, then the while loop will say to itself, okay, 0 is not greater than 0, then I don't have a reason to enter this while loop. So I will go straight forward to this line because this is the only line left to execute. So I will use F8 in here. Then you can see that Python automatically takes me to that line. So this means that now we have totally understood how while loops are working. Okay, so now that we understood how while loop works, we understood that Python will enter the while loop only if the condition near of it returns true. So now that we understood this, let's see what will happen if we will provide a condition, I mean an expression that is always true. So by saying always true, this could be something like 1 equals to 1 like that. So this is a true expression that will be true no matter how I change my program. So as you can see, as soon as I have completed writing this expression, then we ended up by receiving here a warning. And if I actually click on the light in here, then you can see that it says us unreachable code. So what that means, it means that this will run forever, and this is also something that is possible. So if I go and execute that, then you can see that we will always receive the output of you bought a sandwich. Okay, we don't want to crash out our computer, so let's stop that manually. And now that I have done this, then this means that you can select the option of running a program till forever. But actually the main convention to do such a thing is by using while true. So by specifying true, it is just as equal as saying 1 equals to 1 or 2 equals to 2 or 4 greater than 3. Okay, this is just a convention to specify it as true, so we can understand that this conditional will execute forever. So again, this will be the same like we saw previously. Okay, so now let's see the benefits of using while true. So actually, when you use while true, you can combine it with something that we already learned, which is called the break statement. So the thing is, you can always write your loops as while true loops, and then you can decide when you want to get out of the while loop by applying the keyword of break. So let's see something like this in action. So say that I still want to implement the same logic of this program and I want to quit the execution of this while loop when budget reaches 0, because this will mean that I cannot purchase any sandwiches. So now if we were to go inside this while true and say if budget equals to 0 like that, and then say right after it break, then you can automatically see the warning that has been disappeared from here, and this program will not run now forever, because in some time throughout the execution we will hit this conditional and then Python will go and execute the break line. And as I said earlier, the break statement will break out the execution of the associated loop. So in this case, the associated loop is the while true loop, and then this will go out of the execution of the while true. And if we want to see this in action, then you can see that we receive you bought a sandwich 6 times, which is totally making sense, and then we end up by receiving the 0. So this comes from this line, and this means that this is actually another approach how you can solve some problems. You can always use while true statement and then decide in some location inside your while loop when you want to break this out by using if statement and then calling the break if you end up with receiving true from this if statement. Alright, so now that we understood pretty much everything about loops in general, let's discuss about which types of variables you can implement a for loop on them. So to actually explain this, in Python programming language we have a very clear division between variable types that you can apply a for loop on to variable types that you cannot apply a for loop based on them. So to actually show you what I mean, let me put in here some random information that I have just created up. So as you can see, we have some different variables in here, but actually each variable is in a different kind of type. So this is an integer, string, float, boolean, and then we also have list, tuples, dictionaries. So now I want to show you which variable types we can apply a for loop on. And actually those variable types that the for loop will execute successfully, those variable types are considered as iterable variable types. So iterable means that you can apply a for loop on. So let me show you this one. So I will say for, and I will pick just a random variable name. I can say something like r, and then I will use in. And then I will go ahead and use some different variable each time that I want to test out if I can apply a for loop on that specific variable. So I will start with num, okay, and I will say print r like that. Now it is quite obvious that there is no way that you can iterate over integers, because integers does not contain any multiple values in it, so it is not like lists. So this is why if I execute this program, then I end up with receiving object is not iterable. So this means that this is in a kind of non-iterable like that. And you might think that the same approach goes for the name, but actually if I apply a for loop on string, then you can see that it knows to show me each letter line by line. So this means that you can iterate over the characters of your strings, and this is why this is considered as an iterable kind of variable. And now if I try the same thing with fl, which is our next variable, then you might guess right that this is not going to run successfully, and the same goes for isMail, so there is no reason that you can iterate over booleans. So let me paste this in here, so we could mark this as a non-iterable variable type. And now in the bottom three sections, we can totally understand that those are iterable variable types, because we saw a lot of times how we iterated over lists. So let's test that out, and you can see the result is okay. And we can also do that with TPL, so it is also quite important to understand that. Now, the reason that you can apply a for loop in dictionaries, basically, if you think about it, a dictionary could include multiple key values. So if we were to change that to info, so I'm iterating over the dictionary, and if I execute this program, then you can see that it will result in to bring me the key name. Now there are some methods to also print the values only, and we saw similar actions throughout this tutorial. So it is important to understand that it quite makes sense that you can run for loops on dictionaries, and this is why it is considered as an iterable type of variable. Alright everyone, so now that we have covered a lot of new topics that is related to Python, we should go ahead and exercise a little bit. So we should write a program in here that will simulate the way that an elevator works. So we should ask the user input always, and by saying input I mean always till the user decides to get out of the program. So in that case, the user may write an input like a number or basically the string of out. And the point is, if the user specifies a number, then we should write him back a message that says you are on the specified number floor. And if the user writes out, then we should stop the execution of the program, because this will mean that the user wants to get out of the elevator. Okay, so let's try to write such a program, and again I invite you to pause the video and try this by your own first, and I will type in my solution just in a second. Alright everyone, so let's try to write such a program. So let me close the comments in here so we will have a more focused window. Okay, so in the point that we hear something about always asking an input, then we probably know to think about while true, because if you remember, I said that we can write a program that is going to run until some sequence happens, or we can run it forever, whatever we'd like to. So we could start our program by saying while true, and then add the colon sign in here and go inside of it. Now we said that we should ask the user a question until we decide to get out of the program if the user specifies the string of out. So we can say answer equals to an input, and the information that you provide inside the input, if you remember from the very beginning of this tutorial, will be by specifying here the question. So we can ask which floor you want me to take you, something like that. So this really simulates an elevator. Okay, so now that we have done this, then we can start writing some if statements to really condition up between the situation if the answer is out or it is a number. So we will try to say here, if answer equals to out, like that, then we should go and say something like print exiting, and we should let our users know first, and then we can call the break statement right after it. So this break totally makes sense because we want to get out of the while true, and then this will mean that there are no more lines to execute. But in another case where the answer is not equal to out, then we should go ahead and say to our users which floor now they are currently at. So we could say something like else, and we should type a sentence that will say, so let me write in print first, and then we can say something like you are on floor number, and now we can refer to that number of the floor by basically referring to the value of the answer variable, like that. And we should convert this to a formatted string, so let me add the F letter in here. And now I think that it is okay to have this program tested out, so we can go and say run. Now, if I say here 8, then you can see that it shows us back the sentence of you are on floor number 8. And then it keeps asking me about the next floor that I want to reach. So if I was to say here 15, then you can see that it is also behaving as expected. Now, if I was to say out, then you can see that we see the sentence of exiting, so this means that the program works great. Okay, so now that we understood how we can solve such a problem, let's say that we want to complex things up a little bit. So let's say that this building has only 20 floors. So this will mean that if the user was to say 21, then we should throw him a message that says I cannot take you to this floor. So we could write this functionality. Okay, so let me add the additional complexity in here as a comment. So I will say in here improvement, the building has 20 floors, something like that. So we could really remember what we are doing. Okay, so we see that we exit the program if the answer is out. But now we cannot leave the else statement as it is because it is not really okay to accept everything besides the out string. So we could go here and we could say inside the else if again, and we could say answer is greater than 0 and the answer is less than 20 like that. But actually writing the 20 in here does not quite make sense because we should go with less than or equal to like that. But now you can see that the minute that I have completed this, it returns us an error. Now if you remember from the very beginning of this tutorial, I said that the input function will result into store its value as string by default, and you can see that from the tooltip that says in here str in blue color. So this will mean that I have to convert this up to an integer. So I can do that in here. And the reason I don't want to do this directly in here, because if I do this, then the conditional in here will screw up because it doesn't make sense to convert to an integer if I check if it is equal to the out string. So this is why I cannot do that. So let me press here a couple of times Ctrl Z and continue on in this section. So we can say something answer underscore floor. So this will mean that this is really the integer that we expect to have. And we could say here int. So this is the built-in function to convert to integers. And we could convert this to an integer like the following. And now we could change those to being answer underscore floor. So let me override those by the following. Okay, so now this should really work if I go ahead and indent the print built-in function in here one more time inside this if statement like that. So now that I have completed this, then it is totally making sense to go ahead and type in here one more time else and say something like the following. So we can say I cannot take you to, and then we could basically go with answer floor like that. Okay, so now that we have finished improving this program, then we can execute this out. So let's try to run that and test the results. So if I was to say 9, 5, 14, then you can see that it behaves as expected. So if I was to say 21, then you can see that it throws us I cannot take you to 21, and I can also specify a negative number like -2, and you can see that it says us I cannot take you to that floor. Now we can type in out again, and you can see that it says us exiting, so that is perfect. Now for sure there are multiple ways that you can improve this program, and I just noticed that I used here the conditional answer greater than 0, so we assume that we have floor 0, so we can add here the equal sign, and this will be greater than or equal to. Alright, so I want to test one final thing before we proceed to the next topic. So let's say that I want to go to floor 8 now, and after it, let's say that I specify the same number of floor again. Now you can see that it shows us the exact same output. Now it could have been a lot nicer to throw a message in that case that will say you are already in this floor. So this will mean that you have to add one more functionality to this entire program that will check if the given number of floor is equal to what I have provided previously. So this is a perfect challenge for you, and I invite you to try to do this challenge by your own, and let me know how you did with this challenge in the comment section, and to really have a little conversation going on there. So let me know how you did with adding this functionality to this program. In this section, we are going to focus in something that is called Python functions. Now, before I actually focus on what Python functions are, let's actually try to write a very basic program that will count from 1 to 10. Now, if you remember, we can count a range of numbers by using the built-in function that is called range. And the reason I have 11 in here is because in range built-in function the last number is not included. And then, as you remember, the last number will be the step number, so this is why it will count from 1 to 10, but the step will be 1. So if I was to execute this program, then the result is very not surprising. Now in this stage I can ask myself why I cannot write a code that will look like this. So I want to count especially from 1 to 10, and the reason I cannot do something like this, it is because Python does not have a built-in function that supports this special underscore count keyword. But there is actually a nice way to overcome this. We can create our own functions, and we can decide how we'd like to name those functions to really turn the experience of writing a code more friendly. Because think about it, if you grab a bunch of code and you name this bunch of code as a function name, then it really turns the experience of entire coding to really more fun and more organized. So let's see how we can create our own functions, okay? So let's go ahead and try to do that. So I'm going to delete that, and I'm going to go here, and I'm going to delete this from here, so I will just cut those from here. And the way that you can create your own function is by using the keyword that is called def. Now def really stands for a situation where you want to create a function, and right after specifying this keyword you should go ahead and use a name that you'd like to name this function. So in our case this could be special underscore count, okay? And as you can see, PyCharm automatically recognizes this as a function name, so this is why it turned green. And then the next thing that I have to do here is using the parentheses like that, and then I should go and use the colon sign like the following. And then the minute that I press enter in here, then PyCharm will automatically use the indentation to really mark this area as an area that is belong to that function that we name special count. Now I'm going to write the exact same code that we saw in the beginning of this section. So it will be for I in range, and I will use the same information in here. So I will start by 1 and end in 11, and the step will be 1. So here we can say print special count, and let me add the formatted string in here please, and we could go here and say I like that. Now just a reminder, I comes from this for loop because we named this variable I. Now if I run this program, then we might expect to see the results like we saw previously. So I will go ahead and execute this program. Then you can see I do not receive anything. And the reason we don't see anything, it is because the only thing that we have done in here is creating a function. So we have to differentiate between creating the function, between calling to a function. So this is where we create this function, and this will be where we call this function. So it is really important to differentiate between creating the function and to call the function. And if I now go ahead and run the program, then you can see that we receive the output as expected. Now one more thing that is beautiful with using functions is the fact that you can call those bunch of codes multiple times. So say that I want to use these special underscore count functions multiple times in different areas in my project. So I can basically go ahead and call this function multiple times like that. So if we call this function 3 times, then we will end up by receiving the same result, basically 3 times as expected. So you can see that we see everything 3 times. So as you can pay attention, there are a lot of benefits of using functions, and there are multiple reasons why we should use functions when we write some programs. Now, if you think about it, in the near future, you will be able to write more complex programs, and there could be a lot of cases where you want to take the exact same action multiple times. So you might consider wrapping those multiple actions under a function like I have done in here. And it is very important again to differentiate between creating and calling, as I said earlier. In this section we are going to focus on something that is called function parameters. Now let's say that we want to complex up this program a little bit, and let's assume that in each call in here we want to count from different numbers. So say that this should count from 1 to 5, and this should count from 1 to 10, and this should count from 1 to 20. Okay, so in that situation, we might think that changing this value in here is a great idea. But actually, there is no way that I can get out of this with supporting those behaviors in those three calls. Because if I change this to 6, for example, then it is going to change the entire functionality for all the function calls. And the same will happen if I was to change this to 21. So you can see that we see the same behavior in those three calls. Now the way that we can overcome this is by using parameters inside our functions. And using parameters inside our functions means that you are able to receive a piece of information when you call this function. So let's say that this special count function needs one parameter in order to execute successfully. So the way that I can do this is by going here and creating one variable name that will be a parameter that has to be passed in when you call this function. So let's say here that I will accept a parameter that we will name it stop count. And you can pay attention that the second that I have completed this, those three calls are giving us an error one after each another. So if I hover my mouse in here, then you can see that it says us parameter stop count unfilled. So this means that we have to pass in some piece of information in order to make this function to be called successfully. So I will say here 5, and here I will say 10, and here I can say 20, like that. And now you can see that the errors are being disappeared. But now I actually don't do anything special with this stop count parameter that is going to be passed in as the information from here. So the way that I can use the parameter that has been given is by easily referring to that. So I can say stop count +1, like that. And the reason that I add +1 in here, it is because the last number is not included. And further than that, you can see that the color from here has been changed to gray to orange. So this means that basically there is a reference to a parameter inside the function. And now I can go now and execute this program. And you can see that first we have 1 to 5, and then we have 1 to 10. And then later we see count from 1 to 20. So this means that we were able to reach the behavior that we wanted to see. And the way that you can complete those kind of things is by using parameters inside your functions. And remember that using parameters inside your functions could help you to create more dynamic functions. Now, before I go to the next topic, I want to differentiate between two important terms when it comes to receiving a parameter in a function. So this is called a parameter. This is not a parameter. Okay, so it is important to differentiate between those two behaviors. Now here we receive a parameter when we create the function, but here we pass an information to make this function execute successfully. So some people tend to call it arguments, and if you hear me saying argument, basically I refer to a case where I put in additional information to make this function to execute successfully. So I give this function an argument. So it is important to differentiate between a parameter and an argument, because I see a lot of programmers that are being confused between parameters and arguments. So it is very important to understand what is what, and this is especially why I wanted to say that. Okay, so in that case, sometimes when you read the code in here, you might not understand why you see this 5, 10, and 20 in here. And this is because the call of this function is not quite descriptive, and you have to really guess that this 5 is referring to a case where it stops counting. So there are two ways that you can fill in an argument. And the first way will be by that way, basically just passing in the value. But the second way could be by referring to the information that you want to pass in. So if I was to go here and say stop underscore count equals to 5 like that, this will be the same like we have seen previously. So I can do this for this one and as well as this one. Now, as you can see, now the code is more descriptive. So sometimes you want to refer to the parameter name that you pass an argument for, and sometimes you just want to pass it as it is, like we saw previously. So it is important to understand that you have two ways to pass arguments. Okay, so now let's take this program to a little bit more advanced. So let's say that I want to have control in the step of the counting. So this means that maybe I want to count by 2 each time or by 3. So I can go here and use one more parameter that we can name it step. And now I can go ahead and change this to being step rather than 1. So I can go like that, and that will be it. And now I can use here comma and pass in one more piece of information. So I can go with step equals to 1, and here let's say that I want to count by 2, so I can say step equals to 2 like that, and I can go here and as well as passing step equals to 1 like that. So I can say here step 2, and this will make sense. And now if I execute this program, then you can see that first we count from 1 to 5, and then we see that we count from 1 to 10, but you can see that we only see 1, 3, 5, 7, 9, so this is perfect. And then we count from 1 to 20 as expected. Okay, so this is another approach that you want to be aware of. You can accept more than one parameters. Okay, so now I want to talk about default parameters. Now I know that this might be too much information that has to be synced in, but basically there are multiple options and multiple customizations when you go ahead and create functions, and as well as when you call them. So I'd really like to make clear explanations about any option out there before we go ahead and exercise this entire functions topic. Okay, so now let's say that you want to have one parameter that has a default value. Now, as you can see, here I pass step equals 1 and as well as in here. So this could mean that the common option among all those three calls is probably step equals to 1. So maybe I don't have to pass in the information step equals 1 every time that I want to count by step 1. So the way that you can do this is by deciding if the parameter that you create in the function is mandatory or not mandatory. So let me explain what I said now by showing an example of this. So let me delete the step equals to 1 from here and as well as in here. Now I know that this will result in to be an error because we did not pass anything about step. And this means that the step parameter is mandatory. It means that if I don't pass the argument of step, then it will crash the program. So we can turn our parameters to being non-mandatory parameters, and it will be as easy as going here and fill in a default value when the argument of step is not passed. So I can say here step equals to 1 like that, and that will be it, right? You don't have to do anything further than that. So now I can go ahead and execute this program, and you could see that first we have count 1 to 5, and then we have here count from 1 to 10, but it basically steps by 2. And then as expected, I have 1 to 20. Now, let me explain what happened here once again. So the first call of special count is not filled in with the step information. So this is why the function in here said to itself, okay, I don't have the information about step, so I will use my default value, which is 1. And this is why we saw a count from 1 to 5. And in the second case, we passed the information of step equals to 2. So the function went ahead and said to itself, okay, so the step equals to 2 is passed in, then I can override my default value. So this is why we saw 1, 3, 5, 7, 9 like that. And then the same approach for the third call happened exactly like the first call. So this is why it went ahead and started to count from 1 till 20. So it is very important to differentiate between parameters that are mandatory and not mandatory. And you can decide what parameters are mandatory by filling in a default value to your parameters. Okay, so now that we know a little bit about functions, let's try to exercise this a little bit. So we should write a function that will print to our users if the given three parameters supporting the Pythagoras formula. So what this will mean? This will mean that if the passed arguments are 3, 4, and 5, then we should return to our users that the given combo of three numbers are supporting the Pythagoras formula, because 3 powered by 2, which is 9, plus 4 powered by 2, which is 16, is equal to 5 powered by 2, which is 25, and 9 plus 16 is equal to 25. So in that case, we should print to our users that the given combo of numbers supports the Pythagoras formula, and if it does not support, then we should print something else. So first, I invite you to try to do this by your own, and this will be a great and challenging exercise for you, and I will provide the solution in a second. Okay, so let's go ahead and write such a function. So let me minimize those comments from here and type in some function. Now actually, if there is a supported case for Pythagoras theory, then it means that it is a Pythagorean triple. So I can call my function something like is pyth, something like that, to have it as a shortened version. And we could say triple like that. Now, as I said in the comment section, that this function should accept three parameters. So I can go here and say A, B, and C like that. Okay, so inside the function, we should somehow write an if statement that will check if A power of 2 plus B power of 2 is equal to C power of 2. Now, to not have too much long if statement in here, then let's divide it into some steps. So I will start by num underscore AB, and I'm referring to the result of A power of 2 plus B power of 2 like that. So now that I have num underscore AB stored as the value as this math expression, then I can also say something like num underscore C is equal to C power of 2 like that. And now I can basically type in an if statement that will check if num underscore AB is equal to num underscore C. And that will support what I wanted to achieve from the beginning. So I can say in here, if num underscore AB is equal to num underscore C. Now pay attention that we have to specify the equal sign twice. And now if this is actually true, then we should say the combination of, and then it will be nicer to give our users which number they have provided. So I will turn this to an F string and I will say something like the following. So let me type in the curly brackets 3 times, and in each one of them I will refer to each number. So A, B, and C. And then I will say something like supports Pyth law. So I don't really want to write the entire word in here, as it could be complex to pronounce it. So Pyth should be enough, and this is probably the shortened version of Pythagoras. Okay, so in other case, we should return something else. So we could say else. Now inside here, we can say the combination of, and again we could refer to those three in here. So we could type in here f string one more time, and we could say, again, let's copy and paste the curly brackets here and paste this in here. And we could say does not support pyth low, like that. So now we could basically exit our function and easily call the function and test this out with couple of combo of three numbers. So we could say is pyth triple, and we could start with the combo of 3, 4, 5. So we could say 3, 4, and 5, like that. And we could also use this function again with some combo of numbers that does not support this law. So we could just generate 5, 6, and 7, like that. And now if I go ahead and execute our program, then you can see that it shows us the combination of 3, 4, 5 supports Pythagoras law, and in 5, 6, 7 it does not. Now again, as each program that you can develop with any programming language, there are multiple ways that you can efficient and improve this program. So just remember that there are tons of ways that you can improve each Python program, and if you want to do some reverse engineering by yourself, then you are very welcome to do so. But we will actually stop here and move to the next topic. In this section, we are going to learn how we can return values when the function completes to execute. Okay, so in any programming language, we have some keyword that is called return, like that. And this is something that could be extremely confusing when you're just learning about functions. So to show you why do we need to use this keyword in almost every function that we write, let me first give an example of some function that I would like to write here. So let's go and say def square my number, like that. And you can already guess what this function is going to do. It is going to accept one parameter as a number. So let's give it the variable name of num. I mean the parameter name. And then let's try to print out num multiplied by num itself. And if you remember, if you want to use the power in here, then you can call the asterisk sign one more time, and the number right after it will use as the power number. So this approach is also okay. So now if I was to say square my number, I mean calling the function and pass in as the argument here num equals to 4, then there are not going to be any surprises because we will see the number of 16 back. But till that point, we never try to assign the given called function to a variable. Every time that we used function in that point, we just went ahead and called this function without really assigning the value of whatever this function does to a variable. So if I try to go with something like result equals to, so the attempt here is to try to store the result as being the number of 16. So we can do something later with the result of this square my number. But now if I was to say print result, we would expect to see 16 one more time. But actually if I go ahead and print this out, then you can see down below that at first I receive 16 because this comes from here, but the second print, which is here, is actually responsible to display me this none. Now in this stage we ask ourselves what is going on here and why did we receive the none? And the reason that we see none in here, it is because actually each function in any programming language expects to give you some value back when it completes to execute. So what is happening with the square my number call in here? This function says to itself, okay, so the only thing that I have to do is printing this num powered by 2. But since there is no request to return some value back, then I will end up returning nothing, which is why we see none. But if we were to use the return keyword to give some value back when the function is called, then the result variable will end up by storing the value that is returned from this function. So we have to now understand that each function in Python is divided into two important categories. So the first one will be just functions to wrap some bunch of code inside of it, like the following. And the second type of function is actually a function that gives some value back after it completes to execute some lines of code. So to show you how the return keyword works, let me please delete everything from here and change this to something like return num powered by 2. So you'll see that I used the return keyword, but I did not include anything with parentheses. So it is important to remember that the return used as a built-in keyword and not like a built-in function or something like that. So it is important to not confuse between those. Okay, so now that I have completed this, then the square my number function that I called in here will say to itself, okay, so I have to give the value back of num powered by 2 and store this in the variable name that I was assigned to. So the result should have the value of 16. And since I try to print that, then we should expect to see only the value of 16 in my next execution. And if I go ahead and execute this program, then this is exactly what is going on in here. We only see the returned value from here as a result. So the most important point to realize in here is that each function expects to return some value back when it completes to execute. So let me set this back to what it was previously. So we had here the print line and not the return. So this is quite equal to this. Okay, so this is important to understand that the function that are not going to include return none is automatically going to add this line at the end of the function execution. But since Python is smart enough to understand that you don't want to return anything, then it goes ahead and by default returns none. So if I was to test this program one more time, then you can see that the result is quite equivalent to what we saw previously. So this actually is quite transparent and we don't have to specify this every time. But this is exactly what Python will do in the background. It will end up returning none when you don't go ahead and return something specific. Now, one final thing that I'd like to say about the return keyword, it is actually a signal for exiting from a function, and that means that the return statement will always be the last line in whatever function that you write. So if we change this function to being return num powered by 2, so let me type in here return num and power of 2. Now let's try to add some additional lines of code after the return statement. So I will say here print just one more line. Now you could see that this line gives us a warning, and if I hover my mouse in here and click on the light, then you can see that it says us unreachable code, and that is because the function already returned some value back to you. So there is no point to execute more lines of code because the function has done its job. So that is why you are never allowed to write more lines of code within your functions when you declare the return keyword. So that is one more point that I'd like to mention. Alright, so I think that it is a great time to work with this challenge that I call it credit card exercise. So we want to write a function that will receive a credit card number as a parameter, and by the end of this function we should return the credit card number back with this format, basically hiding the first 12 digits. Now, in most of the websites, when you purchase something online and you provide your credit card number, usually right after you provide your credit card information, then you don't really have access to see the entire credit card number. And in most of the cases, it is going to be shown in the following format. So the first 12 digits will be hidden like that, and you will only see the last 4 digits to really have a basic identification of the credit card itself. So this is the exact thing that we like to do. So say that we call this function like that. So we have a function that we could name it hide underscore card, and it will receive one parameter, as I said. And let's say that we send this function this info, then it should return us the credit card number in this exact format. Now, one great hint that I can give you in here is the fact that you can index your characters when you work with them. So say that I really start writing this function, and for sure I will not provide the solution yet to let you do this by your own first. So I will just type in the function name, okay, and I will say credit card, or maybe card number should be enough, and I will enter our function. Now say that I return card number, so I'm returning the value that has been passed in, and I go ahead and use the indexing methods to return only specific characters from this string. So this is quite similar to list, but this is something that we did not see before, and this is actually a great thing that you can do with strings. You can cut your strings off by indexing them exactly like list indexing. So if we were to say here :2, so this is something that we learned in the list section. We learned how we can index stuff, and this should result in to return us the first two characters. So we should only see 1 and 2, and this is exactly what is happening in here. So you should try to go and search for a method to bring only the last 4 digits, because this is what we want, and then you should go ahead and try to figure out how you can generate the hidden characters in here and really return the credit card in the requested format. Okay, so I invite you to do this by your own, and I will provide the solution just in a minute. Okay everyone, so I hope that you had a great time trying to solve this by your own. Now let's provide a great solution for such a task. Now there could be multiple ways to solve such a problem, but I'm just going to show one of the solutions that are possible. Okay, so first, we should look for a way to grab the last 4 digits in the given information, which is the card number. So let me clean our function in here. So I will just delete everything from here. And let me minimize those comments so we will have a more focused look. And personally, I will start by creating a variable that I could name something like last 4 digits, just to really understand what I'm going to store in here. So that will be equal to something like the following. So I will say card number like that, and I will try to grab all the information here. So it should be 3, 4, 5, and 6. And that will be by easily specifying -4 and then the colon sign. Now if you remember, if we specify the colon sign from the right, then it means that it is going to grab everything here. And since the 6 is index of -1 and that is -2, so the 5 is -2, that will be -3 and this will be -4. So this is why I use -4 and then immediately right after it I use the colon sign. Okay, so now we can try to test ourselves by only returning the last 4 digits variable. And if this print line will result in to show us 3, 4, 5, 6, then it means that we done a great job. Now if I execute this program, then you can see that this is exactly the result. Okay, so from here our life will be very easy, because we can just say here something like the following. Now there is really no limit for the variable type that you can use within the return keyword. So we can also return formatted strings, like we can return regular strings, integers and stuff like that. So I can say something like return, and then we could go and open a formatted string like that. Now the second that I have done this, then I can start by formatting the credit card like it was requested. So if you remember, from the question we should return this exact format. So let's grab this from here and paste this inside our string like that. So now that we have done this, then we can refer to the value of last 4 digits. So it will be as easy as calling here the curly brackets and type in last 4 digits like that. And now if we were to execute this program, then you can see that the result is just as expected. Okay, so till that point we can really think to ourselves, okay, this was an easy challenge, only 2 lines of code within this function. But let's say that the given information in here is now not a string, but besides it's a list of credit card of numbers. So let's say that now we pass in multiple credit card numbers and we should return back a list with all the credit cards formatted in the hide card format like we have explained earlier. So now I'm going to generate some more numbers as credit card numbers, but for sure this will contain 16 digits. So let me just type in something like that, and that should be okay. So now there is a little bit more work that you should do with this hide card function, because this function now only handles in case that you pass in one card number, and now we want to make this function more advanced and more dynamic, and we want to make this function to support multiple credit card numbers. So again, I invite you to try this by your own, but first let's change the function name to hide cards, so it will make a lot of sense. And as I said, I will give the solution of that just in a second. Alright, so first, let's start by deleting everything from the previous exercise. And now it is a great idea maybe to change this parameter name to something like card numbers, because now this function should handle multiple credit card numbers. So now we can again go inside our function, and now automatically we have to start figure out how we can perform the exact same action for each given credit card number within a list of credit card numbers. And automatically I have to think about doing this with for loops to be as much as dynamic as possible. So we could say here for card underscore number in card underscore numbers, like that. And then the second that I have wrote this line, then I can add the colon sign and press enter, and this area is marked as an area that is going to be executed within our for loop. Now pay attention that you differentiate between this to what is in here, so this is only related to the function itself. Okay, so now we can write the exact same code like we had previously. So if you remember, we had a variable name that its name was last 4 digits, and that was equal to card underscore number, and we indexed this with the following way. So it was -4 and then the colon sign right after it. And right after this we can again do the same trick by bringing the format that we want to return back as the credit card format. So let me bring the format from the comments. So I will copy that and I will paste this in our formatted credit card. So again, we can create the formatted credit card, and I can make that to be equal to an F string. And the second that I have done this, then I can paste in the format which is hiding the first 12 digits, and I can refer to our last 4 digits like that. Now let me zoom out a little bit so we can see everything. Okay, so now we can expect to write here return formatted credit card. But let me tell you what is the problem doing this. So we are inside a for loop, and doing return statement within our for loop will break the entire execution, because what will end up happening? The for loop will start, and since the first element that has been passed, in that case with hide underscore cards, is that string in here, what will end up happening is that the for loop will stop its execution because of the return statement. And if you remember, I said earlier about return statements that the return statements should be the last line of whatever function that you write. So we cannot allow ourselves to have the return statement inside our for loops. But what we can do instead is we can open up a new brand list outside of our for loop, and we can fill in the formatted credit card each time that we iterate over card numbers. So let me fix that by deleting this line, and we could easily creating a new list like the following. So that will be by saying cards underscore list equals to, and I will make that to be an empty list. And if you remember, we can create lists by providing the square brackets like that. And as soon as I have done this, then we can go ahead and say cards list dot append. So append is the method to add elements to our lists. So we can say here formatted credit card. And then what will end up happening is that each card number will add its formatted credit card version to that cards list. So now that I have completed everything that I have to do in this for loop, then I can allow myself to get out of the for loop, and I could easily say return cards list like that. Now, this little trick with for loops is actually something that I personally always use. So the for loops that you write in programming should help you to take some special actions and to really help you to return all the information in the format that you want. And this is exactly what we are doing in here. So now I can go ahead and test our program. So if I execute this, then you can see that the result is just as expected, because the first element of that list is exactly as expected, and as well as this one. So now we can play around with this and really add some more credit cards. So we can even add here one more credit card, and let's say that I want to add something like this. So let me generate some 16 digits in here. So that should be okay. And now if I again run this program, then you can see that the result again is just as expected. So this function is now very strong to handle multiple credit cards, and this is exactly what we always want to reach when we write functions in programming. Alright everyone, so I hope you had a great time dealing with this challenge. Now, as you can see, there is no limit to the functionalities that you can add to any program. And there is no one way to complete a programming task, although it might look like it is, but there are always different approaches for all the programming problems out there. Now, after a few sections in this video, we will do more projects that will cover generally everything that we have learned, and watching their solutions could really help you to understand a lot of new things. So make sure to follow the tutorial until the end. Alright, so in this section we are going to focus on classes. So before we explain what are classes, let me cover please very quickly all the data types that we have learned that exist in the Python programming language. So what we had until now, we had strings, we had integers, we also had floating numbers, and as well as booleans like that. Now we understand that those variable types are built-in variable types that are existing in any programming language. So thanks to those variable types, we can write different programs. And we also learned about lists and as well as dictionaries and also tuples like that. Now, if you remember, each of those variable types included its own methods. So for example, in strings, we had things like capitalize, and we also had lower like that. And for those variable types, we had its own methods as well. Now, the biggest question that raises up to our mind in here is if we can create our own variable types and to decide its own methods. And the answer for that is absolutely yes. So the way that you can create your own variable types will be with Python classes. So this is exactly what classes are made for. It will allow you to create your own variable types. So say that if in the future you want to create your own variable type, let's say that you want to name it credit card, and you want this variable type have some methods that are going to be accessible like hide, show, or pay. This is something that you can do. And also you could go ahead and create a variable type that you could name it person, and it could include some methods like talk, run, or play. And as well as the same will go if you want to create variable type, say that it's a car and you want this variable type to have drive, stop, or park. Now those variable types are examples to what variable types you can create. Obviously those are built-in variable types that exist in Python programming language, but those are good candidates for variable types that we can create with Python classes. So now that we understood for what we need classes, let's actually go and create one and see how classes could help us to write more efficient and robust code. Alright, so now that we understood the idea of classes, let's create one. And I'm going to rely pretty much on the latest exercise that we have completed about credit cards, so it will make you an easier life to understand the concepts behind classes. And it will also give you a great idea of different ways that you can complete a program. So I will start by saying class, and then Python expects for the class name. So I will say here credit card, like that. Now I want you to pay attention the convention that I followed here. So as you could see, each word is capitalized, and this is the way that we tend to call our classes, and this is considered as a convention when you name your class. And you don't want to include any underscores when you create classes or something in that kind. Okay, so now that we have created our class, basically for now we are not going to include a lot of complexity in our classes, but you can understand that PyCharm expects for at least some line of code to not throw us an error, because you could pay attention how this line throws us an error and it expects for at least one line of code. Now we have a built-in keyword that is called pass, so we can use the pass keyword to not include any kind of code within our class definitions. And this is like saying to our class, don't worry, I will include some code later, but for now just pass, don't throw any error or something like that. So this is why we have a built-in keyword for this case. Okay, so now that we have created this class, we need to instantiate this class. And by saying instantiate, I mean creating some instances of this class. Now, if you remember, I said that creating a class is like creating a variable type on your own. And till now, we used a variable to assign different values in different variable types. For example, this action here is equivalent to saying something like creating an instance of a string. And so if we want to create an instance of this credit card, it will be as easy as saying my underscore card, for example, equals to credit card, like that. And this action could be described as creating an instance of a credit card, like that. Now there is one final thing that I like to show before we continue on designing this class. So let me move this up here and go down. Now I'd like to use the built-in type function to show you the differences, what will happen if I was to say something like print type and then pass as an argument the variable of name. And I will allow myself to copy this line and paste this in and switch that to my underscore card. So now if we were to print the result of this, then you could see how the first line says that it is a type of class str. So you can understand that there is already a built-in class that someone designed to have the functionality of strings in Python. And this is why we see class str. But nobody created the credit card type of variable. We created this by our own. Now I'm not going to focus why we also see this weird output in here, but basically you can understand that this shows us that its type is class credit card. So now we can totally understand what is class and why do we need to include classes in our programs. Now I will be super honest with you here. This is the topic that almost made me quit from programming because I had an absolutely tough time understanding the idea of classes. So this is why I felt like wasting at least 10 minutes explaining those things could be a great basis to understand the complexity that classes bring with them. And don't worry too much if the information does not sink in once. I would recommend watching this section again if you don't feel enough confident with the things that I just said. In this section we are going to learn about instance attributes. Now an attribute is basically a piece of information that is going to belong to that specific instance. So for example, when we have an instance of a credit card, some pieces of information like number, limit, or card's company are a good pieces of information that we can assign to this instance as attributes. So we can do that by easily saying my card dot number, for example, and we could make that to be equal to just a random number that I can generate up in here. And another good candidate could be something like limit, and we can set that to $5,000, for example. And we could also go with this card specific company, so we can say dot company, and we can say, for example, JSC, and for sure this is a company that stands for JimShapedCoding, like that. So as you can understand, we can define as much as instance attributes that we like, but it is important to understand that those attributes are going to be only belong to that specific instance. So to show you that, I am also going to create one more instance of this credit card, and I'm going to use for this C2, and I'm going to say credit card again, and right after it I'm going to use dot number. And as you could see, we might have expected to see now an auto completion for the number attribute, but this is not the case because this attribute only belongs to my underscore card instance. So now we need to create here a new number. So we could generate one more number in here, and I think this should be enough for the examples of how we can create attributes. Alright, so you can also access the values of the different attributes that you created. And this will be as easy as referring to that specific attribute. So I could say my card dot number, and I could wrap this up with the print built-in function, and that will allow us to see its value. So if I run this program, then you can see that we see the number, which is very expected. Now we could do the same with my card dot limit, and as well as with company, and this is going to basically return us back the values as expected. In this section, we are going to talk about something that is called a constructor, and in Python, sometimes people might call it double underscore init, and it is very unique kind of thing when it comes to classes. So before I explain the idea behind that, let me show you the code that I have here. So as usual, we got the credit card class, and we have one instance of this credit card. Now say that I want to create two more credit cards, then it will be as easy as basically regenerating the same information two more times. So I already created a code snippet for this kind of situation. So let me paste this in, and you don't really have to write this in your IDE because I'm going to change what is going on in here just in a minute. Okay, so now we got three credit cards, and as you can see, each of the credit card instances includes some attributes in common. So it is the number and limit, and as well as the company. Now it could have been a lot nicer if we could somehow define inside the class that whenever we create an instance of this credit card, we will have some mandatory information that has to be passed in the second that we initialize an instance of this class. Because now, if I was to scroll down a bit and say something like C4 equals to credit card, then it would allow me to create an instance, although I did not specify anything about this credit card's number, limit, or company. But we totally can understand that this is a mandatory information to basically generate information about credit cards. So to avoid this and to avoid writing those attributes manually, meaning hard-coded, then we can use a special method in classes that is called double underscore init. Now this special method is automatically going to be called when an instance of a class is created. So what that means? It means that if we were to create an instance of a class like in this line, then this double underscore init method is automatically going to be called. So to show you that, let me first clean everything from here, and I just want to remain with an initialization of a class like that. So now I will use this special method and I will create this inside a class. Now just to make some clear points about the terminology in here, when I say methods, basically I refer to functions that are going to be declared inside a class. So when we create functions inside a class that are going to perform some actions for its instances, basically it is more common to refer them as methods. So this is why I might repeat the word methods a lot in this section. So let me create that, and it will be basically by using a special keyword that is called double underscore init double underscore like that. Now, as we remember, we should open and close up the parentheses when we create a function. But now you could pay attention how this is auto-generated itself, and what that means, it means that we already have a one default parameter that this init method wants us to accept. So why it is happening? Well, when you go ahead and you create methods inside the class, then the instance itself is automatically going to be passed in as a piece of information. And so for now, we just have to remember that this self parameter is a reference parameter to the instance itself. So I know that the self keyword might be very confusing when we learn about classes, but as I go further with explanations, then this self keyword will make a lot of sense for you. Okay, so now that we understood that this method is going to be executed when we initialize an instance of a class, then let's see this in action. So just to really understand what this double underscore init does, then I'm simply going to say one print line inside this. So I will say print I am created like that. Now we should expect to see this line once because we created one instance of a class already in here. And if I was to run that, then you could see that we see this line one time. And if we were to create one more instance of this credit card like that, then we should see this twice, and this is exactly the result. So now we totally understand the behavior of this init method. It is just going to be a method that is going to be called when we initialize an instance. Okay, so after that we understood this, then let's see some other benefits of this double underscore init method. Now I'm going to try to give some attributes that are going to be belong to each instance. So what that means, it means that we will create an attribute that will be accessible within each instance of this class. Now the way that you can do that is for sure going inside your double underscore init method and use the self keyword. Now the reason that you can use the self keyword again, it is because it is a reference to the instance itself. So if we were to say self dot number equals to, and then we will end up by writing the auto-generated 16-digit number like we have created always, then now we should expect to have an access to the number attribute from the C1 instance. So if I was to try that, then you can see that it automatically completes me because it recognizes it as an attribute. Now to prove you that, then let me please try to print the value of this attribute. So now if we were to execute that, then you can see that we see the number and as well as the I am created print line that we can really get rid of because we understood the behavior of that. So now if I execute this, then you can see that the number is really as expected. Okay, so now that we understood this, then let me show you the problem going with the approach of assigning a value from the init itself. Now, if we were to, for example, create some more instances, so let me please copy and paste those a couple of times, and I will change those to C3 and 4. And now I will try to use the print again to really access the value of each number attribute, and I will change those to C, 3 and 4 like that. Now if we were to execute this, then we will still end up by having same credit card for 4 credit cards. So we might ask ourselves, is this what we want? And for sure the answer is no, because we probably want to have a unique credit card number for each credit card. So the way that we can overcome this is by accepting additional parameters in this init method. So for example, if we were to specify that we want to accept some additional information, say that we want to accept number like that, then you can already see that those four initializations will going to have some problems. And if I was to hover my mouse on each one of those, then you could see that it says us parameter number unfilled. And the reason for this, it is because now when you initialize an instance of a class, you must pass in as a piece of information the number, and it comes from here. So now I can allow myself to go with something like number, and I will make that to be equal to some randomly generated number again. And I will do the same with this one, and I will repeat that with credit card 3 like the following, and I can do the exact same thing with credit card 4 like that. Okay, so there is one final thing left to do to make this init function to work successfully. Now if you take a look in the double underscore init method, then we don't do anything with the received piece of information that is number. So what that means, it means that we don't really assign to each instance the argument that is coming from here. And I can prove you that by executing our program at this stage, and you could see that we still see the same credit card number when we try to access the instance attribute C1, C2 and so on. So the way that we are going to fix that is by easily changing this from being hard-coded like that to the number argument that comes from all those four instances. So now we should see the unique credit card number for each instance, and if we were to run our program and zoom in a little bit, then this is exactly the result. So now we totally understand how we should create our double underscore init methods, and we really understand the idea of that and how it could help us to make more dynamic and efficient classes. Alright, so now that we understood everything, then let's take an exercise and try to add two more instance attributes to this class. Now if you remember, I said in the beginning of this section, and limit or company could be great candidates for attributes that you maybe want to include inside this credit card class. So try to do this by your own at first, and I will give the solution just in a second. Alright, so now that we have to add two more instance attributes, then it is a perfect idea to create them as parameters inside our double underscore init method. So I will go here and I will type in comma and I will say limit, and I will also say company like that. Now the second that I have done this, then for sure I have to pass those pieces of information in here. So I might say something like limit equals to 1000, and I can say company equals to Jim company like that. And as you could pay attention in here, this entire code in this file starts to look like the code that we had when we started this section, but in that case we are more organized and working now as best practice. So for the second card I can generate that my limit is something like that, and the company could be John company like that. Now let's actually get rid of those two, and I will just initialize two instances and I will delete those. Now if you remember, you also have to assign the received parameter to the instance itself. So it will be by saying self.limit equals to limit that comes from here, and the same approach will go for company. So I could decide that I want to create an attribute for each instance like company, and this will be equal to company that again comes from here. So now if we actually try to access to each attribute, so I will change that to limit, and that will be company, And let's actually do this for both of the instances. So I will say here company, and I will say here limit, like that. Now if I run this program, then you can see that the result is just as expected. Now here's one more little trick that I like to show in this stage, just to really be aware of. So if you remember, when we learned about functions, we said that there might be some pieces of information that are not mandatory parameters. So what that means, it means that we could decide to have parameters that are going to have default values if we don't pass them as arguments when we call those. So the same goes when you work with double underscore init function or method, because this is how we should call it when it is inside a class. So the way that this is going to work again, let's say that for all of our credit cards, we want to have a default limit of $1,000, but for some cases here and there, we will decide to raise the limit to 2,000 or 5,000 or something like that. So the way that this will work is by easily saying again equals to, and then we will have to pass in a default value like 1000. But now you see that PyCharm has a problem with this, and this is because by convention the parameters that are going to have default parameters should be declared in the latest position as possible. So what that means, it means that I cannot create non-mandatory parameter right between mandatory parameters. So I'm going to just change the ordering here a little bit. So I will delete that from here, and I will move this to here, and I have to add the comma here like that. So now PyCharm is okay with this, and it is not going to complain anymore. So now to test this out, let me please remove those arguments from here like that. And now if I'm going to execute our program, then you can see that we have a default value of limit for each credit card. But we can decide for our third credit card, for instance. Let me just copy and paste those, and I will change some of the numbers, and I will say something like Mike company. And now I can pass in limit equals to 5,000, for example. And if I want to test this out, then I can say c3.limit. And I actually forgot to change this variable to being c3, so let me do that. Okay, so now we can test this out, and the last line should return us 5,000. So if we were to execute this, then you can see that this is the exact result. So this is another piece of information that you probably want to know in this stage. There is also the option to pass in non-mandatory parameters within your init method. In this section, we are going to learn about methods in general. Now, as we saw earlier, we saw how the double underscore init was a method that is designed per each instance. And it means that your methods are going to be applied for each of your instances. And it means that you can write methods that are going to perform as unique per instance. So let's say that we want to pretty much perform the same action like we have done in the previous exercises when we try to hide the first 12 digits of our credit card. So to reach such a behavior, then we might decide to go with a method. So I can say here, so pay attention that I am outside of the indentation of this, but I'm inside the class itself. So I could say here def hide, and again this is going to receive the self as a first parameter, because the first parameter must be the instance itself. So this is why we see this convention parameter called self in here. So now if you remember, we can basically decide that we like to hide 12 digits starting from the left, but we will display the last 4 digits. So if you remember, we did this by indexing the last 4 characters of our credit cards. Now when we call this method from our instances, basically we'd like to see a behavior where we override the first 12 digits of the given credit card number. So to achieve such a behavior, then we can access the self.number, which is the value of the number attribute per instance. So we could easily say inside this hide method something like self.number equals to, and I can open here the formatted string like that. And the second that I have done this, then I can start hiding the first 12 digits like that. But now we ask ourselves how I'm going to grab the last 4 elements within the self.number, which is assigned to the number that comes from here in this instance, for example. So we could do this by referring to the self.number. But when I do this, basically I still did not set up a new value of this self.number. So for example, for C1 case, the value that is going to be in here is still this one. So I can basically play around with this and try to index it as I'd like to. Now, if you remember, I said that the way that you can bring the last 4 digits from some previous sessions of this course was to say something like -4 and add the colon sign like that. So this entire thing should go and override the self.number that is passed in from here. But currently we don't call this method, so we should not expect to anything happen yet. So we can verify ourselves by using the c1.number within print block, and I can run this program, and as you can see, we still see the credit card as it is. But if we were to execute the hide method like that, and right after it try to access the c1.number, then you will see that we see the hidden version of our credit card. So what that means, it means that you have multiple options for the different methods that you can go ahead and create them. And for sure you can decide that you'd like to return some value rather than taking the action only itself. So just to not confuse that, this is quite equal to creating a function. So the return keyword will work here. But again, the terminology of when you see functions inside classes are methods. But this should behave like the functions that we learned throughout this course, so you can go with some return statement as well. In this section, I'm going to give a short explanation about the self parameter that is auto-generated. Now, I'm doing this because some of you might still not understand why do we have to pass in the self as a parameter when we create methods. So now, to really show you that, I'm going to comment out this line, and inside the hide, I am only going to say print, and I'm going to print something very basic like hiding, okay, something like that. Okay, so now that I have done this, then let me get rid of those pieces of information, so we will have a cleaner look, and I will delete those as well. So now we only have a credit card class with one attribute that we have to pass in when we initialize an instance of this class. So I want you to take a look what will happen if I was to delete self from here and go ahead and say something like c1.hide like that. Now when I'm going to run this, I'm not going to receive any errors with this line, but the expectations to receive an error is actually from this line. And we'd like to see what will happen if we execute this program now. So if I run this out, then you can see that this hide method says that it takes 0 positional arguments. Now positional arguments stands for the parameters that it receives, and 1 was given stands for the information that has been passed in. So this is equivalent to argument. But if we take a closer look here we don't pass any arguments. So what is going on in here and why it says that it provides 1 argument? Well, what Python does behind the scenes, it passes the instance itself as an argument. And this is why we should receive at least one parameter when we launch our methods. Because again, when we execute some methods that are associated with the instances of some class, then transparently Python already gives the instance itself as an argument. So this is why we should go ahead and accept at least one parameter. And now you might ask yourself, why self? Well, the reason is it is just convention among all the developers out there. This could be something like P or selfless, I don't know, whatever you'd like to, but the self is just a convention. And for example, if I was to say something like custom underscore param in here, then if I was to hover my mouse, then it should show us usually first parameter of a method is named self. So as you can understand, this is just a convention to call it self. But the main idea behind that is the fact that Python automatically passes the instance as a piece of information when it tries to launch its methods. So this is why we have to accept at least one parameter when we create those methods. So one more thing that I'd like to show in this stage is another approach that we can call this hide method. So I will zoom out a little bit, and now let's try to access our class first. Now, since the hide is actually a function that is inside the class, then we could refer to it like the following. And now, as soon as I have done this, then you can see that it expects for an additional argument, and this additional argument is just the C1 instance. So if I was to run that, then you can see that this works. But we already know that this is not the common approach to call instance methods, because in this way we will always have to pass in the C1 as an additional piece of information. But with the previous way, which is the way that we have learned, Python does this automatically. So this is why the self should be here always. In this section, we are going to cover what are the differences between instance attributes to class attributes. Now, as you can pay attention, I still have our class which says credit card, and we got the init method up here, and here we receive number and limit, and we initialize those and we use them as an attribute in our self. And we also got the hide method like we had from our previous sessions. And we only have one credit card created in here, and the arguments that are passed are obviously number and limit. Now I want to talk about a situation where sometimes you would like to create attributes that are going to be common attributes among all the instances. So say that in our credit card we have a raise amount that will raise our card limit if we want to. But this limit is actually always stable and it is never going to change. So in that case, we might consider creating a global variable that is actually not unique per instance, but it is unique for this class only. So what this will mean? This will mean that this attribute is going to belong for the class itself and not for the instance. And those kind of attributes are called class attributes. And creating those attributes will be as easy as going inside our class and basically create a variable in there. So we could say limit underscore raise underscore amount, and we could make that to be equal to 1.5 like that, because we want to assume a situation where the limit raise amount raises by 50%, and if we were to multiply the limit, which is for that instance might be 1000, by 1.5, it will return us 1500. So this is why I can allow myself to store such a class attribute. Okay, so now that we understood how we can create those class attributes, let's see how we can access them. So I am now going to use the print built-in function, and I am going to say credit card, which is basically referring to our class itself, and I'm going to press dot, and then I can access the value of our limit raise amount. So if I print that, then you can see that I receive 1.5. So this is just the second kind of an attribute that you can create when you work with classes general. But now I have to show you something that might be confusing in the first look. Now you might think that if we were to say here C1 besides the class name itself, so it's like I'm assuming that the limit raise amount is an instance attribute and not a class attribute. But if we were actually go ahead and execute that, then we still have the access to this limit raise amount. And the reason for that, it is because when first you try to access to some attribute from an instance, what will instance do at the first step? It will check if it has the attribute in itself, meaning in the instance level. But since the limit raise amount is not existing anywhere as an instance attribute, then the instance will say to itself, okay, so I cannot find this attribute in my instance. Let's try to find this in class level. And then this is why the C1, which is the credit card instance, will know how to pull the value of this 1.5. So this is a very important point to remember. You can create these class attributes, but those class attributes could still be accessed from the instances as well. Now, to really show you what I said in the past 2 minutes, then I'm going to duplicate this line by pressing Ctrl D, and I'm going to change that to be C2, and let's change those to something like that. And I'm going to change this, you know what, I'm going to stick with 1000 in here. And I'm going to execute a following line. So we will use the C1.limit_raise_amount in here, and we will also say something like C2.limit_raise_amount, and we will assign this to 2 like that. Now what will end up happen for the C2 instance is that C2 will know to pull the attribute of limit raise amount from the instance itself. So this is why it does not have to search for this attribute in the class level. Besides, the instance level should be enough. So now to prove you that, if I was to go ahead and say C2.limit_raise_amount, so I'm trying to print that right after I created this instance attribute, then if we were to run that, then you can see that for C1 we still see 1.5 because C1 did not find this limit raise amount in instance level, but actually C2 found the limit raise amount in the instance level. So this is why it showed out the 2 in here. So I hope that you understood totally all the differences between the instance attributes to class attributes. And it is more important to remember how an instance of a class will figure out what is the value when we attempt to access to some of its attributes. So I hope that the explanation about the differences between those was clear. Okay, so now that we understood totally about class attributes, let's try to work with those and create a method and name it raise_limit that will really go ahead and change the limit of each of our credit cards if we call this specific raise_limit method. So try this by your own first, and I will give the solution for sure just in a minute. Okay, so if we go inside our class, then we can go and create one new method in here that we really can name it raise_limit like that. Now, when I go inside of this method, I have to somehow access this limit raise_amount attribute. Now, we might think that if we were to say limit raise_amount, then it will give us access to what is inside in here, but it does not give access to this one with the following approach. So the reason for that It is because this method is designed for each instance. And so if we want to access to class attributes, we still have to dive in first to our class and then access the attribute itself. So now we will have the access for this attribute. But now we should decide what we want to do with this attribute. So what we want to do with that is going to our self.limit and give it a new limit by easily multiplying this one with the existing self.limit. So I can basically say credit card.limit raise amount multiplied by self.limit like that. And whenever we are going to execute this method, then it will override the attribute that has been instantiated in here. So now to make this method to be a little bit more nicer, we could go with something like print, and we could say congratulations, new limit has been set to, and we can refer to that new self.limit like that. Okay, so now that we have done this, then it is a perfect idea to test ourselves. So the way that I will do that is by easily executing the raise limit method like the following. Now I'm going to do the same for maybe this one as well. So I will execute that. And as you could pay attention, I execute this method for both of our instances. So if I was to run that, then you could see that we see here new limit has been set to 1500. Now if we'd like to convert this from floating number to an integer, of course we can do that, but it is up to you. But it is actually not that important. You could do that if you would like to. Now it could have been also nice if we could somehow describe for which card we have changed this limit. So we could say new limit has been set to self.limit for card number, and now we can refer to our self.number like that. Alright everyone, so I hope that you understood pretty much everything about how classes work in Python. Now I know that you might heard about the term object-oriented programming quite a lot, because this is something that everyone that deals with any programming language could talk about. So object-oriented programming is exactly what we started to learn. It is the ability to grab the information that you want to work with and to turn it being under classes, so it will be a lot useful and a lot more efficient to turn the idea of your program into classes, so then you can reuse your functions, and as well as you can simulate data like in real life situations, exactly like we did with the credit cards. So this is what object-oriented programming stands for, and I might create more detailed series about this entire topic. So I think this is going to be the last topic for this entire tutorial, and from now on we are going to proceed and do some real-life projects. Now the projects that I'm going to work in here is basically to show you how a Python project in a little bit more advanced level could look like. So let's go ahead and start. Okay, so we are going to develop the war game, what is so known as a cards game that two players could play. So the point of the game is each one of the players is going to display its first card in the deck, and then we are going to see which one of the two cards that has been displayed has the greater value. Now the one that has the greater value is going to earn a point, and then when two players finish their cards, the player that will have the most points will win the game. So let's see what will happen if we press enter in here. So I'm going to start the game, and the moment that I will press enter, then you can see that it says us P1 card is 10. So this is the value of the card, and P2 card is 1. And as you can see, it says us a point is added to player 1, and you could also notice that it shows us the current score, which is 1-0. So I'm going to keep press enter in here until the cards are going to be finished for each player. And just for your information, each player currently has 10 cards, but since we played one round, then only 9 cards left. So let's keep on press enter a few times and see what happens. Okay, so now we could also notice that we handle a case where the values are equal to each other. So we throw a message that says tie. So now 3 rounds has been played. Let's keep on going. And now 5 rounds, and the score is 3-1 after 6 rounds. So we are going to keep press enter a few times. So now we played 8 rounds and the score is 3-2. So I'm going to keep on going here, and now the score is tie. Now if we press again enter, then you can see that player 2 wins, and it also knew to say us game over, and the final score is 3-4. So this is the program that we are going to develop just in a second. Now if you find this quite comfortable with yourself and you want to go with your way first, then you are more than welcome to try. And anyway, I'm just going to do a walkthrough of how you can develop such a project. So let's get started. Alright, so when we want to come up with a project like this, usually we want to start by planning it. So think about it. In this game we have cards, players, and we are going to have rounds and stuff like that. So we need to think which one of those we want to simulate under a class, so it will be a lot easier to develop such a project. Now, since we have 2 players in this game, and each player is going to have a deck of cards, and each player is going to have its own score, then it quite makes sense to start with a class that its name is going to be player, and we are going to initialize 2 instances of this player class probably later on this project. So we could easily start by saying class player like that. Okay, so now that we have done this, then we want to start designing our init method. So we could say def double underscore init like that and receive the self as a parameter. Now we could give each player a name that could basically describe the player. So we could say that we'd like to accept the parameter of name right here. And now that we have done this, then we can assign this name parameter to the self object itself, like we always did throughout this tutorial. So we can say self.name equals to name like that. Okay, so now we have a player class and each player is going to have a name. So let's say that this is quite enough for now for the player class, and we want to create 2 instances of this player class because this game is played with 2 players. So we can say p1 equals to player like that, and we can specify that name equals to player1 like that. And we could repeat the same process by saying player again, and the name could be player2 like that. Okay, so now that we have done this, we have to think about more attributes that are probably going to be assigned to each player to really have a real-life demonstration of a game being played. So if we think about it, each player is going to start the game with 0 points, and also each player is going to start the game with 10 cards. So now we have 2 more things that we want to add inside the initialization method in here. So first of them should be something like the following. So we can say self.points equals to 0 like that. And the reason I'm doing this and not passing in inside the parameter in here, it is because each player is always going to have points equals to 0 when the game starts. So this is why I can allow myself to directly assign the value of 0 like that. And just a quick reminder for this case, if we were to say p1.points and as well as print p2.points, then this should return us 0 for both cases because there is no problem to access instance attributes, although we don't pass them as arguments when we initialize the instance. So it is important to remember that. Okay, so let me remove the print lines quickly and continue from here. Okay, so now that we have done this, then we want to somehow generate a list of values between 1 to 10 because we said that each player is going to have 10 cards. So it quite makes sense that each card's value will be also from 1 to 10. So this could be done by easily saying self.cards and I'm going to generate a list of all the integers between 1 to 10 here. So if you remember, the range built-in function is going to be quite helpful when we want to do such a task. So we can say range, and I can say that the start is 1 and the stop is going to be 11 because the last number is not included, and the step here could be 1. Now, if you also remember from this tutorial, I said that the built-in range function returns a unique kind of its object. So this is why we can decide that we'd like to convert this entire thing to a list. And it will be as easy as using the built-in list function and wrap this around like the following. Now, if we want to verify ourselves in this stage, then we could say p1.cards, and if we print this out, then you can see that there is a list with all the integers from 1 to 10, so it means that we have done a great job here. Now we could also do the same thing by basically having a variable that says deck cards. So sometimes when you develop projects like this, then you want to maintain as much as variables as you can. So this is why maybe creating some variables that are going to basically describe the game itself is actually a wonderful idea. So let me jump here 2 lines like that and write a comment like game variables, and I'm going to say something like deck equals to 10. So we can really understand that this game is going to include only 10 cards for each player. And now that I have done this, then I can use this variable and put it here and not hard coding the value of 11 in like we did previously. So we can say deck plus 1 like that. And this should be the same as what we have done previously. So I'm not going to test this out. This is just going to return 11. Okay, so now that we have done this, if we think about it, now we have a list that starts from 1 and finishes at 10. Now sometimes when you play card game, then each of the players are going to shuffle its cards to really have a more fair game. So we can use a wonderful function that's really going to shuffle the values inside a list. So this will be by the random library that we really learned about it in this tutorial as well. So I'm going to say here in the very first line, import random like that. And I'm going to jump a line just for Python convention reasons and just for having a cleaner look up top. Okay, so I'm going to go down here. Pay attention that I'm inside the init method, and I'm going to execute a function that says random.shuffle. Now this shuffle method is going to shuffle the values that exist inside a list. So now we should not expect to see 1 to 10, but we should see something like 10, 6, 8, 7, 5, 4, 2, 3, 1, and so on. So I'm going to pass in as a piece of information the self.cards in here. And now we want to test this out. So the way that we can test this is by easily seeing the cards of one of the players. So we can say print, and we can say p1.cards like that. And we should see a shuffled list. So I'm going to print this out. And you can see that it has all the numbers from 1 to 10, but the ordering has been changed. So this is wonderful, and we can continue from here. Alright, so now that we have done this, then we should somehow simulate a situation where we pick a card for each player. So this is why it could be a great idea to write a method that will do the steps of picking a card. So we could go inside our player class and we could create a brand new method. Now pay attention that I'm outside of the init method, but I'm still inside the player class. So I can say something like def pick underscore card, and for sure this will receive the self as a parameter. And inside this pick card we are going to say several things. Now first, we should somehow pick an element from this self.cards list, and once we pick that, then we should remove this element from the list, because in this game we want to decrease the amount of cards for each player. So we could say picked card equals to self.cards, and I'm just going to pick the first element within this cards deck. And the reason that I can do this, it is because I already have this list shuffled because I execute this line, so I can always pick the first card. And now that I have done this, then I should remove this picked card value from the self.cards. So it will be by saying self.cards.remove. And I'm going to remove the picked element, which is picked card, like that. And now we can do something that will really describe the picked card for this situation. So we can say print, and we can write a formatted string that will describe what is the value of this card. So first, let's say something like self.name, so we will be able to describe the player's name, and we can right after it say card is, and we can relate to that picked card value like that. So now if we want to test the behavior of this method, then we can go down here and we can say p1.pickCard like that, and we can do the same for p2. So if we execute this program, then we can see that it says us player 1 card is 10 and player 2 card is 3. Now, if we really want to test out that the cards has decreased from 10 to 9, then we can also do that by saying print len, and we can type in here p1.cards, and we can do the same for player 2. So now if we were to run that, then you can see that we receive 9 elements for each list. So this means that we have done a wonderful job with writing this method. Alright, so now that we have such a method that says pickCard, then it is about time to really turn this into a real playable game. And we can do this by wrapping some lines of codes within a while true. So if you remember, while true is a loop that is going to execute forever, and then later on inside this while true we can decide when we want to get out of the loop by using the break statement. So we can allow ourselves to do something like this in this stage. So let me remove those, and I'm going to start the while true from here, because I don't want to include the initializations inside the while true, because it will keep generating those players forever. So I want to make sure that those two lines are outside of my while loop. And we can do something before this while true, something like the following. So we can say print game starts like that. So we will really raise the awareness that the game has been started. Okay, so inside that, first, I want to create an input function that is just for reasons to have the control for each round. So I can say something like input, and I can specify press enter to pick a card like that. And now that I have done this, then I can go with something like p1.pickCard again, and I can do the same thing for player 2, so I will do that. And now if we want to test our program, then let me zoom out a little bit so we can see everything. Okay, so now we can test the program and see what will happen. Now if we press enter, then you can see that it shows us player 1, player 2 like that. Now as long as we keep pushing with this, then sometime we will receive error because the amount of cards is 10. Now if we are going to press here enter more than 10 times, then there are not going to be any elements left in the list. So I will stop here because this was my 10th time. So I will stop the program now. Okay, so now we want to do something with this picked card, and somehow we want to test which one of the players has won this round. So this is why I have to assign this entire method to a new variable, and I can do that by easily saying p1_card is equal to like that, and I can do the same for p2. So I can go with something like the following. But if you remember, inside our method we don't actually return the value of picked card. So I must do that, and I'm going to go inside the pick card and say return pick card like that. Okay, so now let's go back to our while true. Now when we pick a card, we have to decide somehow who won the round. So we should go with some if statements to check this out. Now we can say here if p1_card is greater than p2 underscore card, then we can basically do something. Now the thing that we want to do here is adding a point to a player. So we can do this by easily writing a method that will automatically do this for us. So I'm going to stop here and scroll back to our class, and I'm going to create a new method that will say def add underscore point, like that. So this add point should do two things, and first of them should be to add a point to that specific player, and the second one should be a print message that will say a point has been added to some player. So we can go with self dot points plus equals to 1, like that. Now if you remember, we learned this from the value increment and decrement section, and this happened to be the section number 23 if I'm not mistaken. You can take a look from the GitHub documentation, or you can basically go back within this course and watch this. Okay, so now that we added a point, then we can say print a point has been added to, and we can refer to that self.name, like that. Now let me fix this print line in here and add the F letter, so it will really be a formatted string. Alright, so now that we wrote this method, we can go again back to while true, and we can say here p1 dot add point, like that. So it makes sense to add a point because now we check if p1 card is greater than p2 card. So now we can allow ourselves to do the exact opposite action. So we can say elif. Now if you remember, this comes from if, else if, and else statements that we have learned throughout this tutorial. So we can check now if the p2 underscore card is greater than p1 underscore card, like that. And if this is the case, then we can say p2 dot add point, like that. And now if we think about it, the only case that we did not check yet is the case that if the values are the same. Because if you pay attention, I did not use any operator that includes the equals sign. So I can automatically allow myself to say else, and in that case we only want to print something like tie, like that. Alright, so let's test what we have until now. So I'm going to execute this program, and I'm going to just basically press enter, and you can see that we have a point has been added to player 1, and we can just keep going and add one more enter line, and now we were able to test the tie case. So you can see that player 1, player 2 card were both 3, and we ended up by receiving tie. And we only like to print the current score after each round. So it will be as easy as going to bottom here. So I'm going to be outside of the if, elif, or else statement. And I'm easily going to say print, and I'm going to use the formatted string, and I'm going to say score, and I'm going to now refer to each of the player's points. So I can say p1 dot points, like that, and I can use a dash in here to have a nice separation, and I can call the p2 dot points, like that. And to test this out one final time, then we can press enter a couple of times, and you can see that we now aware of what is the score. So this is perfect, and we can continue on designing this program. Alright, so now that we have done everything that we done till this point, we want to figure out what are the points that we can allow ourselves to completely get out of the while true and display a message like game over. So we have two cases for this one. And the first one is probably when we don't have any cards left in each of the players. And the second case might be in a situation where a player reaches 6 points, for example. Because if we think about it, when the score is going to be 6-1 and we will have 3 rounds left or something like that, then there is no more point to continue this game, because there is not going to be any change within the player that is won, because the maximum amount of points that the losing player will gain is 3, and then the score will be 6-4. So to test things like this, then again we can write a method that will check if the game is over for each one of our players. So we can go down here and we can write one final method that will say something like the following. So we can say def is game over, like that. Now again, pay attention that this is a method within our player class. Now we basically want to return a boolean value, and the boolean value here is going to be something like the following. So I'm going to automatically start with return, and I'm going to say len self.cards is equal to 0, like that. Now if you remember, we said that there might be one more case that it is worth to check if the game is over, and this was in the case that the points of one of the players is 6. So we can say or self.points equals to 6, like that. Now actually hard coding the 6 in here might be a bad idea, and the reason for that, it is because if you remember, I'm going to scroll up a bit, then we had this deck equals to 10 that represents the amount of cards for each player. Now if one day we were to decrease this to 20 and this one will have the value of 6 here, then this is not going to make a lot of sense, because if each player is going to have 20 cards, then the winning score will be 11, because 20 divided to 2 plus 1 is 11. So we want to write this value dynamically in here, and we can do that with something like the following. So I'm going to create here one more variable, and I'm going to say p underscore 1 underscore score. So now we will change this to 10 again, and besides hard coding here 6, we can just do some math operations to test the winning score. So I can say deck divided by 2, and I can just add plus 1, like that. And I'm going to go down here and refer to that variable and say p underscore 1 underscore score, like that. Alright, so let's go back to our while true now. Now we always want to test if one of the players has already won the game. So this is why using this isGameOver method within the while true could be a great idea. So just before this line in here, I'm going to say something like if p1 dot isGameOver, and it quite makes sense to use here the or and launch this method for the second player as well. So I'm going to say or p2 dot is underscore game over, like that. And if we will enter this if conditional, then it means that the game is over and we have to figure out who won the game. Now to figure out who won the game, then we have to initialize some more few if statements in here to really test this out. So first, we can start by displaying print and say game over and add a exclamation mark, like that. And now we can basically write one more if else statements to test who won the game. So it is not going to be very different from what we wrote previously. So we can say player 1 dot points is greater than player 2 dot points. So if this returns true, excuse me, I forgot the if statement in here. So if this is true actually, then we can say a formatted string and we can relate to p1.name and say wins, like that. Now again, I'm going to do the same for else if p2.points is greater than p1.points, and if this is true, then I'm going to say p2.name wins, like that. So in else case, which is a tie score, then we can say print score is tie, like that. Okay, so now we really aware who won the game after we know that the game is over. Now there might be some more few lines of code that we want to write just to raise the awareness and to show some more descriptive messages. So the thing is, we have to now display the final score. So I'm going to say first print final score, and I'm going to make this to be a formatted string for sure, and I'm going to say p1 dot points, and I'm going to say p2 dot points. So this will display the final score after the game is over, and right after everything within this if statement, then I can allow myself to call the break statement. So this will make sure that the game is going to exit right after we entered this if statement right there. Okay, so now we are totally ready to test this program out. So I'm going to execute it, and let's make the screen bigger in here. So I'm going to press here enter 3 times, and the score is 0-3, and now it is 3-1 and 3-2, and now 4-2. So now 3-4. Now we got a tie. So now we have 2 more rounds left. Okay, so we can see that after the 10th round, then we see player 2 wins, and we see game over, and we also see the final score. Now if we want to test this one final time, then we can go with a couple of more enters in here. And now this will be the final round. Okay, so now we see the game over, and we also see score is tie because each one of the players gained 4 points. And I think everything with this program works. Okay, so I really hope that you like the entire idea of this project. Now this might be some more advanced project rather than what we have developed throughout this entire crash course, but I just wanted to show you this aspect as well of how you can develop some more complex projects when it comes to programming. And I really hope that you enjoyed this project. So let me know in the comment section how you did with this war game, and if you tried this by your own, and as well as if the explanation of my solution was clear for you. Alright everyone, so I'm really happy that you were able to stick till the end of this crash course, and I hope that you had a great time watching this tutorial. And I also hope that I will see you around in one of my other tutorials as well. So if you like this tutorial, again, hit the like button and consider subscribing to my channel, and as well as click the bell button so you can be the first that will know about other crash courses like this. I will see you very soon.